Hello, welcome to session number 0 in the series Programming Languages. And why I call it session 0 is because I am going to cover C language. And C is the mother of all languages because this is the first language before actually, after B, but it is considered to be a full-fledged language, right? So let's go ahead and learn C in this session, and in one session I want to cover the entire C language, right? So I'm very ambitious about this. So I'm going to use Visual Studio for doing that. So first of all, I'm going to make a new project, and I'll show you how to just get started with writing a program in C, and then we will discuss into the other details of language. So what you need to do is you need to create a new project, and I will call this is I'm going to use Visual C++ here, okay, as a project template, and I'm going to create an empty project under Visual C++, and I'm going to call this project as let's say chapter 1 in C. Okay, so I'm going to do chapter wise. In this whole session I will develop the entire programming skills in C. Okay, so let's say okay, and this will show up as an empty project to which I'm going to add a file. Now this is the IDE which you can use for doing the C programming. Okay, so when it comes up in Solution Explorer, you are going to see 3 folders. One is called resources, other is called source, right, and header files, right? So this is a blank project. So under sources, I am going to add a new item, and I'm going to call this as hello world. So that's the first program which anybody writes, and instead of CPP I will give it extension C so that it knows that this is it's a C language, right? So I'm going to say add, and this comes up with a blank this thing, and this has IntelliSense. So as soon as I start typing, so first thing I have to include a certain header file. Now what are these header files? These are nothing but these are the function declarations, right? So if you want to search a header file from the current folder, then you are going to use these angular brackets, and I can say stdio.h. Now if you want to do double quotes, you can also put double quotes around it. That means that it's going to start searching for these header files from the root folder. So once you do that, okay, you have to have a main entry point, and in this case the main is supposed to return something to the operating system, so the return type is int, and then you say main, and then you can say that you don't pass anything to this main, and you just type in here what you want to do. So I want to print hello world, so I'm going to just say print, right? So this is called IntelliSense, right? So this just, once you start typing, it just tells you, right? Now it is telling you what it expects inside this. So it expects a pointer to a character kind of stuff, right? So it may be a string where the string basically is a pointer to the first character in the string, right? So the strings basically are the array of characters, and the last terminating character is a null, right? So that marks the end of the string. So here I'm going to write hello world, and then I can say welcome to C programming. Okay, now so this is good enough. So this is a first thing, and then I can put a comment here that printing to console. So this is rudimentary, but okay. So this is a console application. I'm printing to console. Okay. So this is how you add a comment. You can also do a multi-line comment, okay, like this, and then say this is my course in C. So this is going to be, and I can keep typing, welcome to my course. So what this compiler is going to do is compiler is going to ignore the comment, which is a multi-line comment here between forward slash star and star forward slash. So, and this is a single line comment here, right? So this is how you can do comments. Okay, so now once you have done this, you can save it, and then you can debug without, so you can run this program without debugging, and it will tell you that it is what it is doing. It is building this hello world.c program, and it has a, under debug folder, it has a exe for this program, and there are no warnings or errors, so build is successful. So it says hello world, welcome to C programming. So that's what we were trying to print to the console, and then you can press enter. Now in some cases, when you do it by when you do this using just a notepad and you run it from outside, like using a GCC compiler, then the screen which you have seen, it will vanish as soon as it has done printing, and it has exited the main thread. So this is a main thread. So here for that scenario, I can say get character. So it's going to wait for a character before it exits the main. So it waits for an input from the user. So you can again run this. Okay, so it is waiting for an input from the user, right? So as soon as you enter this, it says press any key to close this window. Say done. So this is my first chapter in C, where I've just shown you how to use Visual Studio to write a C program, and how to write main, which is the entry point in a program, right? And then hash include stdio-h. This file basically has all the functions, right? So now you can see, so I'm going to try to see. Okay, so it says there's main. Okay, fine. So I'm going to stop here for chapter 1, and then I'm just going to follow it with chapter 2, where I'm going to talk on data types, right? Okay. Okay, this is chapter 2. Let me create a new project, and I will create an empty project, call it chapter 2 in C, and say OK. And here I'm going to add a new item and call it data types. So I'm going to talk about data types. Okay, so first of all, I'm going to have hash include, and here I'm going to put in stdio.h, and then I'm going to have int main. So int is the return type from this function called main, which receives a void input, and it is optional to add a return 0, and this 0 is returned to the operating system. So when a function reaches this statement, it returns a 0. But if it function causes so a statement causes an error, then you don't reach here, and then the int is not returned as 0, right? So this is optional here, so I may not use it as in the first program which we have written. Okay, so here we are going to talk about data types. Now the data types are stored in memory locations, or various data is stored in memory location which has various types. And types, by types I mean how many bytes of memory is allocated. So for example, if I look at a character data type, so that is that's how you declare it. And let's say this is C, right? So now here C points, so C is basically a pointer. So C is a pointer to a character at a location pointed by C, at a location pointed by C, right? And this is just a declaration, so no memory allocation is taking place unless I do C is assigned a value, let's say a single quote, and that single quote is X. So C is assigned this. Now what I can do is I can print the value of C, so that same printf is going to work. So just one second. So that printf is going to work, and here it is expecting a string. Now I can put a character, so in that case I have to have a formatting string which says this is going to be a percentage character, right? And then I can say that character is C, and then I can put a semicolon. So basically I'm telling the print statement how to format the value of this character. So the character value is going to be converted to a string before it's being displayed. Okay, so I can say is my character. Okay, and then I can also do this, that holds a value of percentage D. So D basically, so this is formatting, so I can say C comma C. Correct. So first time it is going to print a value of X, and X basically is unsigned int in a ASCII table from 0 to 255. It will have a certain value. So let's just debug this and see what happens. Okay, so X is my character that holds a value of 120. So X is my character. Okay, that character value is 120. Okay, so for example, let's just look at character A, right? So I can just say debug start without debugging, and the character A is 97, right? And what about capital A? So it's case sensitive. So if I say capital A, okay, and I run this again, so that's a 65, right? So 65 is capital A, 97 is a ASCII value, 97 is a small a. So you understood that what I mean by formatting the formatting string, right? So here this is about character. Now let's go to so character is again an integer type, but then it's an unsigned int, okay, or unsigned value, right? And character, let's add some more. Character is 1 byte. Okay, so if I go here and I say hash include, and there is another include file I want to include, which is std int. Okay, so this has a predefined type. I can say size t is going to be character size is equal to size of. So this is another keyword. Size of is a keyword. Okay, and then to this size of I can give C. So that being done, I can say printf, Okay, and here if you want you can put here the escape sequences, right? So I can do, right, so let's see if this works. If it's a backward slash or forward slash, I get confused, but let's see. Okay, so here I can say this thing, and this is going to be a integer type, right? So size t is an integer type, right, which is a type it is declared in std int, right? So I can say printf percentage d and character size. Okay, so that's that. Okay, and I can just do this. So I can say dash bytes is size of uh, let's say percentage c, and say c. Okay, so having done that, just gonna save it, debug it, start without debugging, and says a is my character that holds a value of 65. 1 bytes is size of a, right? So you understood what that size t is. Okay, it is an integer type which is declared in stdint, which I could have said int, and I could have done that. It will have the same effect. Okay, so now, so character basically stores this thing. Now let me try one more thing. I can say again here I'm going to do a forward slash n. So this is a new line character. It's a escape sequence. I can say printf. Okay, here I can say memory location, right? So I can say percentage p. Let's see, is the memory location of percentage c. So I am going to do here so this is going to be c, and this is going to be c. Let's see if I have done mistake. So am I doing a mistake here? Okay, I usually get confused. Okay, so let's do this and let's see what it builds. Okay, so a is my character that holds a value of 65. 1 bytes is the size of a, and 0x0116F-A83 is the memory location of a. So at this location I'm storing the value of this. So I can do one more thing. Okay, so here I can also do pointer to a character, and this is a p which is assigned at c. Now here, okay, that's not how we do it. There is a character and there's this. Okay, now let's put this line afterwards. So here is the allocation, and then I'm reading this thing, and I can say print f percentage. So there is a formatting string percentage p, which is the pointer, is the location of percentage c, and then here I can put here p, and I can put here c. correct? So here that also works. So at C, so that's a pointer, and so P is also a pointer pointing to the same thing, right? Okay, so now I can again do this, and here you see, okay, again I forgot to put the new line character, so let me make a correction here. Let's put here a new line character here. Okay, so I'm just gonna save this and start without debugging. Okay, so this is the location of A and this is the location of A. So I have used a variable P. Okay, now with the pointers I can do one more thing. Okay, I can say okay, so I can say pointer, so the okay, so I can increment the value of the character. Okay, so just like integer, so it behaves internally like an integer. So I can say C plus plus, C plus plus, does it work? So increment the value of C, and then I am going to say this. Okay, so I'm going to just copy this, I'm going to place it here, insert a new line character here. Okay, so now the character should have changed to B because its value of 65 is incremented to 66, right? So now if I was to debug this, okay, B is my character that holds a value of 66. So a plus plus basically is just doing that. Now if I want to do this another way of doing this would be the content of C plus plus. But the issue here is it's going to increment the pointer, or is it going to increment the pointer, or is it going to increment the character? And pointer to the character at location C must be a pointer. Okay, so does that work? So does that work? Yeah, that works. Now this might give me a garbage because it is incrementing the pointer or the content, so that's what we are trying to check. Okay, so if I do this again, okay, and if I run this again, debug, so let's see what it's gonna do. Okay, B is my character, its value is 66. So the value of, okay, so the pointer is updated, but let's see what it is pointing to. Okay, so that means that it's not the content. Okay, is the precedence is 2 plus plus the pointer. Okay, so instead of writing this, let's see what happens over here. Let's copy this one over here. So let's say what this pointer is. Okay, so that's a value of P, and pointed to a character. Okay, so yeah, so that will be the content of p, which will be a pointer. So let's run this again. So I am just trying to see what happens. Okay, so now you see that the location of B is going to be the same, 0059FB8B, but it is pointing to a different location now because the... So let's see one more thing. Is that gonna work? Okay. Okay. So this is all garbage. Okay, so this is the location where the pointer value is stored. So this is quite confusing here. So I am not going to go into, I don't want you to focus on this. I want you to focus up to here. Okay, so this is a character which is a single byte. Now this is character is also of type int, and this is unsigned character, right? Character is an unsigned int. Now the base type is int. Okay, so now here I can say int. Now here one thing is there in the C89 version, all the declarations of data type should be at the top, but here I can do anywhere. So int I, and I can do it on the same line. Declaration as well as definition is, let's say, 23. Okay, so I have put in here a value of 23, right? And I want to check what's the size. So I can say size t, which is declared in std.h, and I can say int size equal to size of I, right? And then I can look at a pointer. So this is a pointer to an integer, and that is going to be pi is going to be location of I. Okay, so first of all I am going to say printf %d. So this is again integer type, and this is going to be int size. Okay, and then I am going to say %d as that. Okay, okay, so with this I am going to just run this. Okay, 4 byte is the size of 66. Wrong. So just one second. Here I need to put here I. Correct. Okay. Okay, so I am going to run this. It says 4 bytes is size of 23. Okay, so at this memory location 23, but 4 bytes are reserved for storing 23. Okay, and this is pointed by I. So now here I just want to see whether the allocation is contiguous, right? So I can say allocation is contiguous, right? Okay, so here I am going to print the printf, and here I'm going to say formatting string and pointer, and this is the... Okay, just one second. Is the location. of percentage %d and new line character, comma. So this is going to be pi, comma, and I. So this 23 is stored at what location? So I'm just trying to see if the memory allocation is contiguous. Okay, so I'm going to here say build start without debugging. Build error, would you like to continue? So no. Unresolved, printf, unsigned, returning int. And this is line number 19. So this error is over here. Character 26 percentage %p unresolved symbol print function main. Okay. Okay, let's try this again. Okay, I'm going to put you on pause till I figure out what's happening here. Okay, so maybe there is a typing error. So I have written the location, okay, of I, right? I can also repeat this as I. So I'm just seeing what location pointer is storing. What is the memory location? And it is not contiguous. This is A27. So this is A00 is the location of 23. And 4 bytes are used for this integer, right? So similarly, there is another integer which is called short. Okay, and this short is, let's say, is going to be 2 bytes. So it's going to be signed again. So I'm going to use, so MSB is going to be the memory, the sign bit. Okay, so let's say again I do here 54, right? So that's a short, and I would say again size t is going to be short size equal to size of s, correct? And here I am going to say this here again and say is the size of percentage %d. So this is going to be short size, short sizze of s, correct? And then I want to see the location. Okay, so I'm just going to do this. Okay, is the location of s and s. Okay, so let's run this for experiment on short. Okay, so here 2 bytes is the size of 54, and this is the memory location. Okay, is the location of 54. Okay, fine. Okay, so these are the various integer types. Now there is a qualifier which is called unsign. Okay, so now if I was to store 129 in C, okay, so let's say C is assigned again 129. So C is a character, right? So EC is an unsigned character, so it will be able to do that. So let's look at a short, right? So S is assigned, so short is 2 bytes, right? So 16, 65536, so it will be half of that. Okay, so the size of short will be 2 raised to n minus 1, so that will be 15, 2 raised to 15, 65536 by 2. Okay, so 65,000. Okay, 32. Okay, so if I give it a number, something like 35,000. Okay, now this is incorrect, but let's see what it does. Okay, so this is an overflow. Okay, so let's print this again. Okay, and let's see the value of S. Okay, build. Okay, so now you observe this, that the value has exceeded what S can store, right? So it is doing a wraparound, right? So it is going to take a negative number out because MSB is 1, right? So it will become a negative number, right? Okay, so now let's do another thing. Okay, let's say I have a unsigned short. Okay, and this has a value of, sorry, unsigned short, and let's give this as sh is equal to 35,000. Okay, and here I do the same stuff, right? Again, I will just verify what's the size of this unsigned short. Size t u short size is equal to size of sh, correct? And here I am going to copy this line. Okay, u short size of sh. Okay, so this is still going to be 2 bytes, but then it can hold this 35,000 value. So let's do the location and the value, sh and sh, right? So let's debug this again. Okay, you see here that now it's able to store 35,000, right? The same 2 bytes can store 35,000, which earlier couldn't, because MSB is a signed bit, right? So that becomes a negative number, right? So you understand how under the hood these integer values are stored. So you know character, you know short, you know int. Then there's something called long. Okay, and li. Okay, so now if I want to store this value, define a value for this li. Okay, so I have to, it's not an integer, right? So I cannot just say 23 as that. I have to say 23L. So that means that this is a long integer, right? And then I am going to just look at the size of this. Okay, and I'll say lint size of li. Okay, and here I am going to print the size. Okay, and L in size of Li, right? And then I can see here the location. Okay, the location of Li and the value of Li. Again, by default, anything which doesn't have a qualifier, it is going to be a signed integer, right? So long is also an integer, but it is stored in 8 bytes. Now this is all dependent on the compiler, right? So let's debug this. Okay, so 4 bytes is the size of 23. So again, it is storing same as integer, and this is the location. So now let's try another one. So long is also using 4 bytes and int is also using. So let's see how the long goes. Does it work? Let's see. If the long can be long or long can be int, right? LL is equal to 23 LL, is it? Does this work? I'm not sure. Okay, so I am going to say this. I'm going to say L long. LL. Okay, so let's print this. Two things. Okay, so here, what happened? Okay, L long is the size of LL, and the location of LL, the value of LL. So let's see what happens now. What is long? Okay, so 8 bytes is the size of 23, and the location of this is 23 is this. So same 23 is stored as integer, same 23 is stored as long, same 23 is stored as long, right? And then so this is called a literal. Okay, so to differentiate, so if I just put 23, it will be an integer, right? But then if I put a L following that, that means it's a long. And if I put double L, it will be double long. If I put UL, it will be unsigned long. Okay, so now unsigned short is done, right? Okay, so now let's do one more thing, which is floating types, right? So I can say float, and I can say f is equal to a value. Now this is supposed to have a decimal, and that means let's say 23.6. okay, now by default this is going to be a double if I just mention a literal like that, but if I add this will be a float, right? So now having done that, I can use the same line to see the size of float. So float is going to be 4 bytes if I am not wrong. Okay, float size of f, and let's print that. Control C, Control V. But here this time I have to put here %f, and this is going to be float size, which is integer, float size, and then this is f, and the location of float f is going to be %f. Okay, so having done that, let's build this. Okay, so 4 bytes is the size of 23.6, and this is the location of 23.6. So this is a floating point number. Great. Now let's do a double, and I will say D is equal to 23.6. Right? Now I don't have to mention anything in the literal because this is by default. And then I can say, copy these 3 lines here. Okay, and I can say double size D, okay, is so many bytes of, again it is going to be F only, so this is going to be D and this is going to be double size DOUBLE, double size, and this is location of D, this is the value of D, and that's going to remain the same. So now if I run this, okay, so 8 bytes is the size of this and the location is this, right? So now the double is using 8 bytes. So the next thing I'm going to do is going to do a long double and see LD is equal to same 23.6, right? And I'll just copy this piece of code and repeat it over here, and I will call this as L double size is the size of L double, and L double size L double, and L double, and L double. Okay, so just run this and see what happens. Okay, so 8 bytes are still used for long double, right? And the location is over here. Okay, so now this is the internally how these various data types are represented, right? And if I want, I would just do this, that I will just turn it into a comment. So I am now having nothing. Okay, so I'm going to do some more experiments with this data types. Okay, so now there is a fixed size integer. So now these are implementation dependent. So if you want, you can use a fixed size. So for example, I'm not going to go much into detail. I can say int 8. So this, if it is supported, okay, or Visual Studio supports this. Okay, so this is a type which is making sure that it's going to take 4 bytes irrespective of what the compiler is doing, and I can say this is fixed int, okay, is equal to, let's say, integer value 23. Okay, and this basically is defined in stdint.h. Okay, so I can just do this, that I can just copy these, Control C, Control V, and fixed int size, f int size of fixed int. Okay, and here this is going to be f int size, and this is going to be fixed int. Okay, and this is going to be location of fixed int, and this is going to be the value of fixed int. Okay, so now I'm looking at a definition of this. So this is going to be 8. So this is going to be basically 1 byte. So 23 will be stored in 1 byte. So this is equivalent to a short, but I'm assuring that this is going to be 8-bit. Okay, so this is fixed size integer or float, can be done like that. Okay, so 1 byte is the size of 0 0 as the location of 0 0. What happened to the assignment? Okay, wait a second. I'll put you on. So formatting string had a small problem here. Right, so let's go back to here. Okay, percentage %d I forgot. So let's debug this. Okay, so 1 byte is the size of 24 and it is stored at this location. Right, so now I just want to add few more things here. I can do something like something which is beyond. So I'm going to use 8 bytes for an integer, right? So I can say int. So this is really equivalent to a long. No, not even long because long is still implementation dependent and it is doing 4 bytes only. So let's go here to fint, and this one is going to be still 25, let's say, and let's repeat these lines again. Okay, and ff is the inside of fint. Okay, ff in size and fint and fint and fint. Right, so let's run this and see whether it's using 8 bytes. So this is going to be precise. You tell the compiler that I'm going to use 8 bytes for an integer, not the 4 bytes which a compiler decides. So let's debug this. It says 8 byte is the size of 25 and this is the location of 25. So now this basically is about that, and then there is additional something called bool. So this bool is a boolean and this can store a value of 0 or 1. It should be same as a bit, but let's see the size of this. Okay, whether it's a byte or a bit. So boolean flg, it's a flag, is equal to true. So boolean is true. So what's the problem with this? Okay, boolean is a undefined identifier. So let's see if I have hash include std bool dot h. Correct. So now it has disappeared. Okay, so boolean flag is a true. Now I want to see the size of boolean. So whether this works on a boolean. So I can say bool size of flg, and is it going to be percentage %d or is there something called percentage %b? I'm not sure. Let's see if this works. And this is a bool size, and this is going to be flg, and this is going to be flg. Okay, and so this, I don't know if percentage %b is there, but let's try it. If I was a compiler designer, I would work that way. So what happened? Didn't show up anything. Run without debugging. Okay. Okay, so I will do this as D, this as D. So am I stuck somewhere? Is it trying to do something? So I have broken this. Right, so let's build this. Let's debug. So nothing is coming. Oh, because it's behind. Sorry about this. Okay, let's look at this again. Debug. Start without debugging. Okay, so what is it saying? 1 byte is the size of 1, which is Boolean, and this is the location of 1. So this is true is 1. Is it same as an integer? Yes, it is same as an integer. Okay, so now I do this as a false. So it's still using 1 byte. False. And I'm going to do a start without debugging. So it should come up with the value of 0. So 1 byte is the size of 0 byte. So this is false, and this is the location of false. So basically that covers various data types. Now two more things I want to mention. Okay, what I want to mention is if you specify or declare or define int here, okay, lint g int, so this is going to be a global value, and any function including main can use it. So that's the visibility, but the global has a scope as long as the main is there. So it has a span as long as main thread is there. So now if this was if anything is declared inside main, as soon as the main finishes, or any other function, as soon as the local function the data type which is or variable which is local to a function, as soon as that function is exited, those values are lost. Okay, because they are stored in the stack. Okay, while this global is stored in a special location. Okay, and it is there till the main is there. Any other function, okay, if you declare, it will be local, but here it will be a global variable, and it will be accessible to any of the functions. So its visibility is to all the functions, but its span is as long as the main thread is there. So with this I am going to conclude chapter 2, right? And then let's see you in the next chapter. Chapter 3 in C deals with operators and their priorities or the precedence, right? So let's go ahead and do that. File, new, project. I'm going to create an empty project and call this chapter 3 in C, where I'm going to explore operators. Okay, and I'm going to add a source file. Call this as study opt. So I'm going to study operators. Okay, and at the top I'm going to say hash. So first of all I'm going to just list out various operators in C, right? And as per the precedence, so the highest precedence is for the bracket, and then the same level of precedence is for indexing, for dereferencing, and then there is one lambda operator again for dereferencing, and then there is let's say x post increment and post decrement, right? And what else is there? Nothing. And then second line of precedence would be bitwise negation or one's complement, then logical negation, which is this, right? And then pre-increment and pre-decrement, and then typecasting, then size of, which you have used earlier, and the content at a location. Just a second. Oh, okay. Let's see if it does that. Okay, so the content of the location and the pointer, right? And then below that there are arithmetic operators like divide, multiply. Okay, so let's not put that way. Modulus and multiply, right? So this is next in the level of precedence, right? And then plus and minus, and then the left bitwise left shift, bitwise right shift, and then less than, equal to, greater than. So comparison, greater than, equal to, right? And then we have got bitwise logical operation. Okay, before that we also have equal to or not equal to. Then we have got bitwise logical operation like bitwise AND, bitwise XOR, bitwise OR. Then you have got logical AND, then you have got logical OR, then you have got assignment operator, and then you have a compound assignment. So that will be compound assignment, and then you have a comma. So this is a list of operators as per precedence. Okay, now I'm going to just do some exercises here. Hash include. Okay, and I am going to include stdio.h. Okay, so stdio.h and probably std_boolean.h, std_bool. Hash include std_bool.h, sorry, std_bool.h. Okay, so I'm ready to write the code. So I'm going to have an int main void. It receives nothing, returns an integer, and here I am going to first look at the bracket. Okay, so I can just say printf, and I can say the value of 2 plus 3. Okay, so 2 plus 3, so plus has a lower precedence, so into 6. Okay, into 6 is %d and new line, and this value is 2 plus 3, 2 plus 3 times of 6. Correct. So that's that. Then I can also say printf. So you can see what is the change in precedence with the bracket. The value of 2 plus 3 6 is %d, new line, and here I'm going to say 2 plus 3 6, and that's it. So the difference between the two you can see. So I'm just going to run this. Okay, did I do something? This is inside main, right? Okay, spelling mistake, print. Okay, so let's do this, print. Okay, Okay, so the value of 2 plus 3 into 6 is going to be 30, and the value of 2 plus 3 into 6 is going to be 18 plus 2 is 20. So 5 into 6 is 30, and 18 plus 2 is 20. So you can see here that this bracket is used for changing the precedence, right? So whenever you are confused about the precedence, it's better to use these brackets. Okay, so now that is out of the way. Now another thing is, let's say this is an integer a, and then I give it an indexing. Let's say that this is an array of 3 elements in a row, right? So that's being said, I can assign each one of them in a for loop, which we'll cover later. Int I equal to 0, I less than 3, I plus plus. So this plus plus is basically an increment operator, and what it does uh, is so let's do this. Let's see how the indexing works. A0, so the 0 index basically is going to be, let's say, 1. Then I have A1, the 1 index is going to be 2, and then I have A2, that's the index, third index is going to be 3. Okay, so I'm going to print here, print f percentage d, and here I'm going to create a gap and print it on the same row as AI. So this is how you handle matrices in a for loop. Okay, so once I do this, I'm going to print all the values of A. So I'm going to say start debug. Right, so I have 1, 2, 3 assigned, so that's 1, 2, 3. So let's look at another example. I can look at what this A is. So basically, if I was to say integer pointer, okay, so pointer to a integer is pointer A. Okay, so then I can say printf array A starts at location. Then I can do %p for the pointer, and then I can type here. So before that, I want to do one more thing, because there is going to be a new line I want to put here, printf. Then I can put here a new line character. Right, so now here the pointer is going to be p. So that's the location pointed by p. Okay, so let's build this, and yeah, so printf, did I do a typing mistake? Again, I did a typing mistake. print. Okay, so let's do this again. Okay, so array A starts at location this. So let's see, so how the arrays are stored. Arrays are stored linearly. Okay, so I want to prove to myself that's what's happening, right? So then I can say, okay, second element in array A is, I can say %p, and then I can say p++. So, and what I want to do is, okay, I want to be clear on precedence. So first I'm going to increment this, and I'm going to look at the content of this location, which should be 2. and this would be percentage D. Right, so the second member in this array is 2. Right, so that's how the pointers are incremented. Okay, see, the array A starts at location this, the second element in array A is 2, then I want to say at what location, right? So let's do this. Is 2 at location. Okay, so neither of this increment or decrement is changing the value of P or pointer. And here I would say percentage P. Okay, so this is not incrementing. Yeah, this is going to be incrementing, right? So P would be pointing to the next location. Okay, I don't want to do that. Okay, so I want to see whatever is the location here. And then now after this operation, it will be pointing to the third location, right? So it is incrementing P, finding out the content at pointer P, then it is printing out the pointer P itself, right? So that's fine. So it's going to find out the print the incremented pointer. So I'm going to say start without debugging. Okay, so it says array A starts at location this, second array element in the array is this at location this. So 3, 8 and 3C. So this is the integer, so I have to add 4. Okay, let's see what happened here. So 8, 9, 10, 11, 12. So 12 is going to be C, correct. So you see 3, 8 and 3C has a gap of 4 bytes. And so one integer is stored in 4 bytes. So the next location it has pointed to is 2, which is the second location. And this is where it is stored, right? So this is how the pointers are working here. An array basically is just the name of the array is just pointing to the first element in the array, pointing to the memory location which is storing the first element of the array. So that is what array is, right? You can do this in 2 dimensions also, and in that case also you can prove to yourself that all the arrays are stored in linear fashion in the memory. Okay, they are all contiguous. So that's all I wanted to prove here by indexing. Then this dereferencing operators I will cover later on. Now this is post increment and post decrement. So the value is used, or value of x is used wherever it appears, and then it is done a post increment or decrement. In the other line you have a pre increment and decrement. So here you see this is a pre increment or a pre increment here. Okay, so this kept aside, let's look at the so we know that this is a pointer, right? And this is basically the address of A. So that's a pointer address of A. Okay, and we have already seen this size of. Okay, and now this is called casting type. So let's say you are doing integer A is done, right? B is equal to 2 and C is equal to 3, right? So if I was to do the following, printf percentage, I can say B divided by C is equal to percentage D is equal to percentage d. So b by c would be equal to 2 by 3, right? So that's what I'm trying to print here. 2 divided by 3. So this is going to be a arithmetic operation of division. Okay, so now this one I can also do the following. Printf b divided by c and equal to percentage f, and everywhere I'm going to put here a new line. Okay, so let me put here a new line here. Okay, so a new line character. Okay, new line character, a new line character. Okay, so let's see what is 2 by 3 in another case. Okay, so I'm going to do 2 by 3 here. Has it done anything? I don't know yet. So next thing I'm going to do here is, so float of 3, or rather I would say, so this is not correct, float of 3. Okay, so I am going to divide 2 by float of 3. So now what it's saying is, this is going to give you 2 by 3 as 0, because it's integer division, and this is also going to give you 0.0 because it's still integer division, though you put f here. And then here, first of all, there is going to be a conversion. So this is called widening. So integer is stored, let's say, in 4 bytes, and float is stored in 4 bytes. Okay, so this is a widening still. Okay, so it's going to convert one of the integers to float, and that means that it has to convert 2 also into float before it does a float division. So earlier it is doing integer division. So now let's see what happens. Okay, let's close the previous window and let's do this. Okay, so you see here b by c is 0. B by c, even if the formatting is float, but it's still integer division. B by c here, it is a float division here, right? So that taking care of, this is called typecasting. So usually typecasting is going to be widening an element, okay, which in some languages is going to be by default, and then in narrowing is not by default, but in C narrowing is also by default. So if you do a float, okay, and you do a casting of float to a int, it is going to truncate that. So I can do here, let's convert this to int. Okay, so let's write another statement here. Okay, so I am going to cast this to int, and so it is going to do the division first, right? So I'm supposed to do a bracket here. Okay, so it is going to do a division first, which will be a float division, and then you cast it to int. The number I'm going to expect is 0 here, and even if I put here float, I'm expecting 0 here, right? 0.00, because it is doing a truncation. Okay, so here you can see b by c is 0 0 again, right? Okay, so b by c is 0 here, integer division with float formatting, float division, and then after a float division I'm doing a typecasting to int, which is narrowing. So the answer is going to be still my 0.00 because it has truncated 6666667, right? So that's that. So that is called type. Okay, so now you know what is division. This is modulus and this is multiplication. So division you have already seen, multiplication you know what it is. Now let's look at the mod. Okay, so I can say print f b by b mod c is going to be equal to percentage f. So modulus works only with decimals, or only with, sorry, integer types. So if I was to do a 3 by 3 mod 2, okay, so I'm going to expect okay, so I'm going to expect a remainder of 1. So let's do that. Okay, so I haven't done a what did I do here? Oh, that's the reason. Okay, just bear with me. Okay, so here this string is not going to accept this because this is a special character. So now this makes sense. So this should return 1. Okay, so b mod c is 1. Okay, so that's mod operator, and divide and multiply you already understand, right? So plus and minus also you understand. Now they say another operator which is a bitwise shift. So let's say the value of c is 3. Now I'm going to use another thing which is called unsigned character. Okay, and I'm going to say d, unsigned character d is equal to 3. Okay, so now I'm going to left shift it, right, and see what that is. So if you left shift it by a bit, so I can say d multiplied by 2. So if I left shift it, it will be a multiplication by 2, right? So in this case 3 left shift by 1. So I'm going to d left shift by 1. So I'm going to take 1 left shift it. So this should be equal to 6, right? So that's there. And then I can also print one more for the right shift. Okay, I can say d by 2 is going to be the right shift. Okay. Okay, so now I am going to look at the left bitwise shift. So whatever number you put here, that many times the bit is shifted either to the left. In this case it's shifted to the left. In this case it is shifted to the right. Debug. Okay, so multiplication of d by 2. Okay, because if you left shift it is going to be 6, but if you right shift it, it's going to only 1 is going to remain. 1 is going to drop off from the LSB, so you have only 1. Okay, so if you left right shift a 3, it will become 1. Okay, so you understood the bitwise shift operation. Then the comparison. Okay, so I'm going to say a boolean flag. Okay, and I'm going to say flag is equal to 2 greater than 3. Okay, so the answer is going to be 2 is not greater than c, so the flag is going to be 0, right? So I can say printf is 2 greater than 3, correct? And I will say flag. So the answer is going to be no. So answer is going to be 0. Then I can say, so here I will put here a new line character again and the percentage d. Okay, so %d and a new line character. Okay, then I'm going to check if 3 is greater than 2. So is 3 greater than 2 %d, then I'm going to put here 3 greater than 2, right? So let's check this. Debug, start without debugging. Okay, is 2 greater than 3? Answer is no. Is 3 greater than 2? Answer is yes. Now similarly you have a equal to, right? So I'll just write one more statement for equal to. Sorry, here is 5 greater than equal to 5? Answer is going to be yes, which is going to be B1. So I'm going to say this. So is 5 greater than equal to 5? Answer is yes. Okay, so that's that operator. Greater than, equal to, less than, equal to, less than, greater than, and equal to, not equal to are going to be similar, right? So I'm not going to go into this. Now this is going to be an AND operation, right? So bitwise AND operation. So I'm going to use, so I have unsigned D, which is 3, right? Then I can have an unsigned E, unsigned character E is equal to 4. Then I can print a bitwise AND of this. So I can say, I'm just going to copy this, and I'm going to say bitwise 2. So this is going to be D is 3 and with 4. So 3 and with 4 is going to be 0, right? Percentage D, okay, and a new line character. And here I want to say D bitwise AND with E. What's the problem? Unsigned character D and E. What wrong did I do here? Bitwise 3 AND with 4 %D is this. I don't think this is the problem. Yeah, this is the problem. Okay, so this is going to be a bitwise AND operation. Okay, another thing I'm going to do is bitwise OR operation, XOR operation. So the answer is going to be 7, right? So this is going to be a bitwise XOR operation. And then if I do a bitwise OR operation, the answer is still going to be 7, right? So this is that. So I'm going to say debug, start without debugging. So the bitwise, okay, so let's just change this. This is going to be XOR, and this is going to be a OR operation. Okay, so this is a bitwise operation. Okay, so AND is going to be 0, OR is going to be 7, and XOR is also going to be 7. So that is going to be a bitwise operation. Next is logical operation, right? So the logical operation is very simple. I can take the two logical outputs, which is Boolean. I can say here Boolean 2 greater than 3. This is AND with, so this is the result of 2 greater than 3 is a Boolean, which is logically ended with another boolean 3 greater than 2. The answer is going to be false. Results in %d and new line character. Correct. And then I am also going to say a OR operation between the two logical outputs. Okay, I can say OR this, right? And okay, here I am going to do a logical AND. So I'm going to say 2 greater than 3 and with 3 greater than 2. And here I am going to do a OR operation. 2 greater than 3 or with logical OR with 3 greater than 2. So the output of the first statement is going to be 0, and for this one is going to be 1. Okay, so let's do that. Okay, so boolean, this results in 0 and this results in 1. So this is going to be called a logical operation, right? Then you can do a plus equal to. So basically you can take any operation and then say a sign. So for example, here e is 4, right? So I can write e plus equal to 3. So 4 plus 3 is going to be 7, and I'm going to printf, okay, the value of e is now %d and new line, right, and comma e. So we start with 4 and it's going to be 7 over here, right? So this is going to be a compound assignment here, an assignment you know already. And commas we used in the assignments, like you can do int f is equal to 3 comma g equal to 5. So I'm not going to use this, but there's a comma there. Okay, so let's just run this for the last time. And here the value of e is now 7. Okay, so that's a compound assignment. Okay, so let me see if this allows me to do one more thing. Okay, int g is equal to int g conditional assignment. I don't know if this is going to work. Conditional assignment. Okay, f greater than g. So that's a condition. Then you're going to say f, else you're going to say g. So basically it doesn't accept a conditional assignment. So in C you do not have this conditional assignment which you have in other languages. So that doesn't exist. Okay, so that basically wraps up conditional operators, right? And see you in the next chapter. Yes, so let's go to chapter 4 in C. And in this chapter I'm going to talk about pointers and related topics, and the related topics are arrays and string. So I'm going to create a new project, and that's going to be again an empty project. Okay. Sometimes Visual Studio takes time to create a project. Okay, so that's an empty project, and I'm going to do chapter 4 in C. Okay, so that's an empty project here, and I am going to create a new item, and that item is going to be a C file. So I'm going to say uh, learn pointers, and the extension would be C. And here I'm going to first talk about pointers. So let me just do a standard hash include, and here I want to put stdio.h. Okay, and then I want to create a main with a void passed onto it, and so I'm all set to learn pointers. So a pointer is a memory location to any data type or any variable of any data type. So I can say, for example, earlier I did this integer, and that's how you create a pointer. And this is a pointer to a integer, right? Now here this is a null pointer because nothing has been assigned to it. So if I was to do a printf on this one and say this is null pointer, and I would do percentage p, and I would put here p, and I am going to run this one. Okay, the printf, did I do any mistake? So it is a null pointer. Is it because of that it doesn't print the value? It's a pointer, it's a null pointer. So now, so that gives a error, right? So let's see, int a equal to 5, right? And now let's see if this works. Debug, start without debugging. Okay, so it seems like there is a where is the error? Integer, pointer to integer, again it is not assigned yet. So when I do a p is assigned the address of a. So now this is done. Let's see what happens now. Okay, this is a null pointer, but this is not a null pointer now. So earlier it was a null pointer. So I can say this is pointer to a. Okay, the pointer to a, or I can say the address of a. The address of a is this. Okay, so here that's the address of a. Okay, so now, so this is the address of a. Now I can manipulate a variable by writing this way. I can say a plus plus, so that will be a is manipulated, right? So here I can print the value of a. So print f updated value of a is percentage d, a new line character. So here also I'm going to put a new line character. Okay, comma a. So a is this time it should print 6. Okay, so the updated value of a is 6. So that's updated. Now let's try to update the value another way. I can say the content of pointer. Okay, so this is the content of pointed by this is going to go through plus plus. So now it should be 7, right? So if I print a, then it should print 7. Okay, so it's updated again, okay, through a pointer rather than the name of the variable. So basically a is basically a location where the value of a is saved, and p is also the location, same location. Now what I can do is I can put another pointer p1 equal to, let's say, a. Now it doesn't create, so I have to tell it integer to it's a pointer to integer. So now I have created another pointer, same variable a. Now I can still do the same thing, is I can increment the value which is pointed by p1 now. So now this is going to be 8, is the same a is going to be, sorry, so same a is now going to be 8, and I can also print it this way, the content of p. So there is a link between p and p1. They are the same, they are same address, but they are stored in themselves, stored in different locations. So there are 2 pointers to a same variable here. Okay, so now the updated value is 8 of a is 8, and updated value of 8 is 8. So all the pointers a, p and p1 all are pointing to the same location, right? Now let's look at another case of a pointer to a pointer. So I can do a integer. So this is a pointer to a pointer, let's say r, and this is storing the location of p. Okay, now if I say the address of a, the address of a is content of r. So the address of a is content of r, so that would be correct, right? That would be same as the address of a, okay, because it is content of r. So let's see that. Okay, so again this is 0133 FCBC, so this is 0133 FCBC. Okay, so this is a pointer to a pointer, and I can say again the updated value of a is something like this. Okay, so this is also correct, right? So let's do this. Debug, start without debugging. Okay, so the updated value of a is 8. So I'm using pointer to a pointer, and then I'm dereferencing it. Okay, and at times when earlier I had a issue, I could have said integer, okay, integer pointer to integer b equal to 3, for example. And okay, so here I don't want to declare, for this example, so it doesn't have a value, so I can say b is equal to null. So this is how you can do that. Okay, and let's try to print the address. Okay, so I can say printf printf, and I can say here the address pointed by b is %p, and let's see if this gives an error again, compile error. Okay, so that's that. Now let's say, okay, the address pointed by b is this. Okay, so I think it has taken this as a character. So let me do one more thing. I can write here, there is a keyword called null, right? So let's run this again. Okay, so now it is pointing to 0 0. So basically null refers to 0 0. So earlier I did a character, so I think I put a escape sequence wrong, so that's fine. Okay, so with this we are done with pointers. Now let's look at arrays. Arrays are nothing but pointers to the first element in an array, right? So for example, if I have an array, arrays are defined this way: integer, let's say c, and then I add, just one second. Okay, so now I can say c has a certain size. Let's say it has 3 elements. Okay, so this is the way an array is initialized. This is a single dimensional array, so it is also called a vector. Now inside memory everything is a vector, so even if it's a 2-dimensional array, so I can also do a int d and say this is a 2-dimensional array. Okay, and d is also a vector, c is also a vector. Now let's see how the storage is. Okay, so I can say pointer to an integer. So let's me first initialize it. So right now, does c have a value? Let's see, printf, and I can say, okay, so I can basically write all the elements. So I can use a for loop, for, and later we will come to how to write a for loop. Int I is equal to 0, I less than 3, and then I plus plus, sorry, and here I can say print f, formatting string %d, because this is an integer, and I can put in a space to separate them out, and then I can say ci. So let's see, try to print before even assigning an array. Let's try to print. If it lets you print, then you will know what is the nature of an array. Okay, the address pointed by b is, where is this? What happened here from then to now? Oh, so basically there is no new line character here, so that's confusing. So let's put here a new line character. Okay, so now it is going to have a garbage. It's not initialized to 0. As you know, in some languages the arrays are initialized to 0, while here it's a garbage. Okay, so without initialization it's a garbage. Okay, so let's do the initialization first. I can say c 0 equal to 1, then I can say c1 equal to 2, then I can say c2 is equal to 3. Okay, and now let's run this again. Okay, so we have written 1 2 3 here. Okay, so that's fine. Now the same thing could have been done with a pointer, because c is nothing but a pointer to the first location. So I'm going to first here do a printf and type here a new line feed. Okay, so this is called a escape sequence. We'll come to this later on, right? So let's now do the same thing with the pointer, right? So here, what do I need? So whatever is the address pointed by, so the address pointed by C, okay, plus I. So initially the I is going to be, so the address pointed by C plus I. Sorry, this is going to be content of C plus I. Does it work? Okay, so basically I equals 0, so the content of C would be printed as 1, then 2, then 3, and so on. Let's see if this works. Okay, the same result is there. So what it means is that C is nothing but a pointer to the first location, right? You could have done it differently also. You could have said integer pointer to integer, let's say is k, and the k is assigned a value of C, the pointer to the first element of C. And then here you could have said the content of k plus I. Okay, so it will have the same effect. Okay, so it has the same effect. I'll run it again. Okay, it has the same effect. So what it means is I can treat arrays as pointers. Now let's say what happens to D. So D can be assigned there itself. So let me just show you another way of assigning this. So this can be assigned as so now everything is linear, so it's expecting 6 elements, right? So I could have written just 6 elements as 1, 2, 3, 4, 5, and 6. So these are the 6 elements, right? So now let's display this. Okay, so for that I need 2 nested loops, and later when I cover loops, you will know what I'm doing. But the way to do a for loop is have a indexing variable starting at 0, then comparing the final or terminating case, and in every loop at the top of the loop it is going to increment by 1 till it reaches a terminating condition. Okay, so here I'm going to have 2 more statements, another for loop which is going to be for the second index, int j equal to 0 and j less than 3. Now I would not recommend you to use I or j because this is also used for complex mathematics some cases. So you will lose I and j. So how would you represent a complex number? So you can use another name for it instead, but I'm using I and j. So this is going to be j plus plus, and here I am going to do a printf, and here I am going to print percentage %d and space, and I am going to print here the content of D. Indexing is I and indexing is j. Now let's look at the so this is running row, so there are 2 rows only and 3 columns, so that's fine now. Okay, so after that I'm going to do one more thing, which is going to be printf and insert a new line character, right? So here I can say new line. So after every row I'm going to insert a new line. So that's what's happening. So I'm going to run this, and what did it do? Okay, let's see if I forgot a new line somewhere. So I should have repeated. So after printing this, I should have repeated this one. Okay, now it's okay. So it's going to print again. Where did I change this? Oh, I did a mistake here. This is 3 and this is number of rows 2 and this is number of columns. Fine. Okay, so I'm going to run this again. Okay, so 1 2 3 1 2 3 is from the previous one. Now this is 1 2 3 4 5 6. Okay, so this is your D. 1 2 3 4 5 6 D, right? So really inside they are linearly stored like this. Okay, and the D could have also been initialized another way, which is going to be this and this. Does it make sense? Let's see if it builds and runs. Okay, so let me just save this. Debug, start without debugging. Okay, so let me just close this. Let's run this again. Build, debug, run. Okay, so same 1 2 3 4 5 6 is there. So another way of assigning this, and by the way, this is basically the last index will take on the size. So just 1 second. Is it this? Yeah. So the row will take on the size from here, right? So it need not be specified, you know. It's just that you need to know the size of the inner, the size of the row. But how many rows are there, it will depend on the declaration itself here. So this is optional here. So it still works, right, without error. So I'm just saying that this index takes from the assignment itself. You need not specify how many rows are there, right? Only thing is you have to worry about what are the inner dimensions. And in reality, it basically is stored inside as a contiguous memory. So I can print, for example, I can say pointer to integer. Let's say that pointer to the integer is going to be IP, and that is assigned a value of D. And let's say I want to look at I want to print the value which is in the second row and second column, which happens to be 5, right? So I know this is going to be 1 2 3 4 5. Okay, so I have to print def, and then I can see here fifth second row and second column stores, right? And over here I can say the content of IP. Okay, and this basically is, the content of IP. So let me put it as a semicolon. Okay, the content of IP is 0, is that 0 1 2 3 4, fourth location, right? Plus 4. Okay, so I have incremented the pointer by 4. I have not incremented, actually I'm referring to the fourth location from IP. It should return me 5, and I should put here %D. Okay, and before I do that, I am going to print here a new line characters so as to avoid confusion. Okay, so now I'm going to build that. Okay, so second row and second column stores 5. So 0 1 2 3 4. So the fifth location from the pointer is basically 5. So this just proves that inside the memories are contiguous for an array. Okay, now one more thing is there. When you increment this, okay, the IP value is not incremented by 1, but it is incremented by 4 into 1, because each one is a integer, so each one is stored in 4 bytes. So I'm saying go to the 4 times of 4, that means the 16th, or 4 times of 5, that is the 20th location from the start, because each integer is stored in 4 bytes. So the 5th integer is going to be stored on 20th byte, right? So this is going to be taken care of by the declaration itself. So it knows the data type and then it multiplies by that factor. Okay, so this basically is going to be arrays. Now there are some special arrays, like for example I can say character array, okay, name is equal to, I can say, so here I don't know the size of the array, but that's okay, because in my declaration it should take that, right? Let's say a, why is it, yeah, n, so I can say u, I can say r, I can say a, then I can say g. So that's my name, and do that, and then I'm going to print the, so basically a string is nothing but a pointer to a character array of a character. So it is going to be pointing to a, capital E here. So I can here say print f, and for strings I have to say %s and comma. Okay, I have to put here another character, otherwise it will not be recognized as, okay, it will not be recognized as a string. Let's see if this is correct. And here I can say name, okay, and here let's put here a new line character so that it doesn't mess up. Okay, so let's see what happens now. So there is a forward slash. Okay, so I did a mistake or what? It should be this. I don't think so. Okay, debug, start without debugging. So it's printing only the first character. So it hasn't taken a string. Okay, so what if I put here a null? Okay, and I can say start without debugging. Still prints a, it doesn't print the entire string. Okay, so this is not comprising a string yet. Okay, so let's do this. So we will come and see what has gone wrong. I can specify string as this in double quotes, and then by default it is going to put in here a null space characters, which marks the end of the array. So let's say, okay, so now it has printed the entire name Anurag. So I need to figure out why the terminating character is not taken. But anyways, so let's look at the terminating character. So I can say printf, I can say %d, so I can say length of string is %d, and I can say here size of name, correct, and I'm going to divide this by length of a character, so that's only 1 byte, so no need. So that will give me 1, 2, 3, 4, 5, 6, 7. So now it's going to give me the length as a 7 bytes. Length of string is 4. How come? Hang on a second. First of all, length of string is size of name, and name has got 7 characters. It says array 7 characters, size of name. So why is it reading as 4? Let's do this again. The length of string is 4. How come the length of string is 4? It should be 7. Ah, okay. It's taking this as a string. So this is what it is doing. It's taking NAME, size of string. So here, just hold on a second. Okay, so I'll tell you what happened. Here, this size of is going to work on array only. So had it been declared as a character array, and it's going to still do a 6 characters plus a null character, so that's 7. So now it's going to be okay. So you have to be careful what's going on. So it can find the size of an array, but if you put in a string, it will give you the number of characters in that string. For example, in this name there are 4, NAME, so that's why it was giving 4. It was not referring the name as a pointer to this string. So with the strings you have to be careful about this. Okay, so having said that, there is the string are special kind of arrays. Okay, according to me they are not stored in stack, they are stored in heap, right? So you cannot change them. You have to create a new one. So a new pointer would be assigned every time you make changes into a string. So there is a include file, and that include file is string.h. Okay, so string.h allows you to do some more functions. So for example, I can do char, and this is pointer to a character, and that would be first name. Okay, and then I can call this as Anurag, and then I can say character. So there is nothing called string as there it is in other languages. It is always a pointer to a character or an array. And last name is Nigam. Okay, so I can do strcat. So I can do printf, and I could do this. My full name is, and then I can do here %s, and here I can put here str cat. Okay, and here I can concatenate 2 strings, which is first name comma last name. And what it is going to do is it is going to remove the null from the first name, and then it's going to follow with last name and then put the null over there. So the 2 strings are combined to make a new string. So this pointer would not be same as the pointer Anurag, or it may be. We can check that. Okay, let's see if this works. Build Debug start without debugging. Okay, so there is a issue here. Okay, what happened to this function or variable may be unsafe. Consider instead to disable strcat_s. That's how it works. This is in string.h. So let's see. Too few arguments to call. Destination resize bytes. So this was the thing of the past, I think. Okay, so that means that this is deprecated, strcat, right? Still, okay, so that's okay. Let's do this way, because this is not a function call. It doesn't return anything. Okay, that's why it is giving this, and the pointer would be the first name. So I can type here first name. So now I'll tell you what happened. Okay. Okay. That is strange. So that's behaving slightly strange. Okay. Unsafe. Okay. So let's do this. Let's really find out where is the problem. Okay. Oh, if they are declared as arrays, not as pointers, then it should work. Okay, so there is a difference here. You should be careful how this is handled internally. So this should work, right? So this should work. Let's save that, and let's say debug start without debugging. Now so does it give you any trace? One failed. No. Line number 47, strcat. So it's over here. So it is not doing that concatenation. It's not doing the append. Even if it is so this one, now there is a destination it is asking. Is it resize byte size and then the source? 6 plus 5, 11, 12. This is going to be strange. So basically I would have to educate myself on this one. What is underscore s? So by default it should have worked this way, but it is not working. str cat is not working. Okay, so let's try another function. Okay, from the same string.h. Let's see if that works. So for now, let me just see. Okay, my full name is Anurag. So here, let's put a new line character. Okay, now I can say is first name same as last name, and then I'm going to use strcmp, and this should work, right? First name comma last name. Here there's no resizing, right? So let's see. Here I'm going to create a space and then a new line character. Okay, so I'm going to do a debug. Okay, is first name same as last name, and it is returning -1. Okay, so let's do one more thing. Let's put them as equal, and let's see what it returns. Okay, so if they match, it's returning 0. If they don't match, it is returning -1. So that is strcmp. Then I want to check copying a string. Is copying the string same as assigning? Okay, can I say last name equal to first name? Okay, so that's a pointer to an array, and I can say this as first name. Now I'm assigning a pointer here, but it is not necessarily assigning the value. Okay, so in this case it's always going to return 0, right? Because both are pointing to the same location. Okay, it gave nothing. It gave nothing. Okay, exit code is not 0. Okay, so now let's do this. Character to this thing, and this thing is same as first name. Okay, and let's do this again. Is first name same as last name? 0. Okay, so now it points to a thing that when you store a character in an array, that string is different from this string, right? So that is a note which we make here. Now this is pointing. Now I can also say last name is equal to, so I can, instead of that, I can make it a null, and no. Okay, so I want to prove to myself that if I do this, then the pointers are same. Okay, so I want to put pointers, 2 pointers. Okay, so pointer to first name, percentage %p, and then a new line feed, pointer to last name %p. Okay, and here I can say first name comma last name. Okay, and here also I do. Okay, let's run this. Okay, pointer to first name is this and pointer to last name is this. So in doing so, we have just made another no, we have made another copy of a pointer. Now if I do this, I can say strcpy and the destination is last name and comma first name. That's the source. So now I'm making a copy of it. Okay, so here I have that. Control X. Okay, so I have made a copy of this. First name into last name. Are these two different pointers? That's what we want to see. Again, there is a issue. Okay, so it is saying use this. So what's the syntax for this? So destination resize t size in byte constant character source. Okay, so here destination is last name, resize t byte. Can I do size of first name comma source is first name? Does that make sense? Now let's debug this. Again there is a problem. Uninitialized local variable last name used. Uninitialized local variable last name. What do you mean by that? You mean by is this I have to do this? Okay, so I am not clear about what are these new functions which are there. So I have to educate myself and then again make a video on string.h. So I am going to do a control C here and I'm going to stop this chapter over here. I could not do anything with the string.h. So this is for the future. So I'm going to stop here and see you in the next chapter. Thank you. Shift. Chapter 5 in C is on iterations and loops, right? So let's create a new project. Okay, so we are going to name this as chapter 5 in C. And this is going to be about conditionals, like, if, then else, and switch statement. And it is going to be about loops, like, while, do while, and for loops. Okay, so here I'm going to study. So I'm going to insert a new item under sources. And I'm going to name this as study branching looping .c. And here first thing is hash include, and then I'm going to do stdio.h, and then I'm going to have int and main is receiving void, and then I can start writing. So it is based on condition, right? So I want to branch based on condition. So I can say let's say okay, int, so int x equal to 6. So this may be a user input, and then I can say if x is greater than equal to 6, then I'm going to say printf entry is greater than or equal to 6, or equal to, you can do a %d, and here I can say, or I can put here 6, doesn't matter. Okay, so this is a very simple statement. If a condition is there, then you execute this statement, otherwise you do nothing, right? So there is no question of otherwise. So if I have an otherwise clause, I can say else printf entry is less than 6. Okay, so now this is very simple. It's a binary branching here. If the x is greater than 6, then I'm going to print that, otherwise I'm going to print that, right? Okay, so entry is greater than or equal to 6, right? Now I can do multiple, right? So for example, I can say, okay, if x is less than 6, less than equal to 6, then I can say is less than or equal to 6. Else, if, then I can follow it with another condition here. I can say if x is less than equal to 20, and then I can do a pipe operator, or basically OR. Okay, so I can say this, correct, and I can say an OR operator, or sorry, AND operator. So if x is less than equal to 20, and so logical operator is AND x is greater than 6, greater than 6, correct, then print entry is between 6 and 20. Is between 6 and 20. Then I can follow it with this else. Okay, and this else is the remaining conditions, right? So this final else is for all the remaining conditions, right? So this goes like a ladder. So this else is reached only when neither of these conditions match, right? So if any one of them match, you are not going to reach to any other else statement, else if statements, right? So as soon as the condition matches, this if statement is going to pass on the control execution beyond the last bracket, right? Or beyond the last brace. Then here I can say print f entry is greater than 20, correct? So now if I have to reach the last else, then I should have declared this as 21, right? So in that case this will be done. If I do x equal to 18, then it will be printing between 6 and 20, and if I do else x equal to 5, for example, then it's going to execute the first one, and then when it executes the first one, then the execution control is not going to shift to else if, or it will skip all the else's after that. It will directly shift to the end of the if statement. So this is, let's check this. Okay, so the entry is less than or equal to 6, because right now I have entered 5. Okay, let me just enter new line characters here also. Okay, now I make this, let's say 15. So then the second statement will be executed, right? Okay, now if I make this one as 25, then if neither of these conditions are true, then the remaining conditions is this one. So that's what it is going to do, right? Okay, so let's see that. Okay, so the last statement is if is greater than 20. Now the same structure could have been written differently, right? It could have been written this way, that I can do a multiple branching. So this is, every step is a binary branching. So that was if statement. Now I have a switch, and then this switch is based on, let's say, integer, right? So I would have to say int x is equal to, let's say, 5, or let's say 3, right? So I can say switch, it's followed by this. Now this is like a compound statement. So if x has a certain value, so case 0, right, then I need to execute a bunch of statements which can be within the braces, or it can be a single statement, right? So in a case of single statement, I won't read these braces, but if I want to put multiple statements, I can say printf, and I can say here, and every statement has to be terminated with a semicolon, right? Printf x is 0, right? I can also say printf, so I can put here a new line character, and again I can say printf invalid x, right? Again it has to terminate in a semicolon, right? And then I can put a semicolon here and follow with another statement, which is break. So if it is 0, it is going to execute these two statements, and then it's going to break from this switch statement, right? I can say case 1, case 1, I can say printf, okay, non-zero number, non-zero number 1. And again, if I have another statement, I can do that. Or if I have only single statement, I need not put these curly braces, and I can do break. Now break means that the execution is going to break from here to the end of the switch statement. So it's not going to test other cases, right? So I can say case 2, then print f, the number is 2. Okay, and here I can do another thing. Here I can say that check the x again. Okay, and I can say here continue. So continue is not going to break it, but a continue statement may only be used within a loop. So basically this will not allow. So that means that only break is possible here. Okay, so the last one is like all the remaining conditions I can put here. I can put here default. So the default is a keyword. Printf neither, I can say here neither 0 nor 1 nor 2, right? And that's the end of the switch statement. So if it is 3, then it will directly go to the default. So let's debug this, and here everywhere let me put here a new line character so that it is clear. Okay, so now here I can build this, run without debugging, and here says neither 0 nor 1 nor 2, and then that's the end of the statement. Now if I put this as 0 and if I run this, it's going to print two statements. X is 0, invalid x, right? So that's what it has done, and then it breaks away from this statement at the end of the braces and goes to the next statement. Now I can do one more thing. What if I remove this brace? So in this case it continues checking, right? So then it is going to check if case is 1, then it's going to print this and then break. Case 2, then it's going to print this and then break. Now if I remove all the breaks, then it will automatically execute a default, right? So it will print x is 0, invalid x, and then print neither 0 nor 1 nor 2, which is not what we want, right? So that's why the break was there. So this is called fall through. Okay, so this is going to fall through. So let's see what happens now. Okay, so x is 0, invalid x, okay, and then non-zero number 1, okay, number is 2, case 2, neither. So it has printed all of them. So basically it didn't even check here. It didn't even check here case 1. It has only checked once, right? Because there was no break, it went to the next statement. It says case 1, then this should not have executed, right? Case 2, they should not have executed. Then this would have executed, right? So that means that switch is only testing these conditions only once. Otherwise, this would not have been printed. Now, this is something new for me because it's not supposed to do that. This would be as good as saying I could have set this as Okay, I could have set this as case. I can remove this. Okay, so what I'm going to do is I'm going to remove this portion by a multi-line comment. Okay, so now I have only default here. Then I can add here one more case 1 comma 2 comma 3, and this should work, isn't it? Oh, it doesn't allow you multiple cases, so some languages do allow you. Okay, so in C this is not allowed. Okay, so that's fine. So there are one takeaway here is what I expected didn't do that. I expected that if it is checking case 0, then it will do this, then case 1, then it should not do this. It should not do case 2. But it did, right? So this is called a fall through, but I was not expecting that it will not check it. And it even did the default one. So you have to be on guard, when you do something like that. So it's a good idea to always check a condition and break it out. Right. So now let's check if this is 1. Okay. Okay, so non-zero number 1. That's what it printed. Then let's make this 2. So I think per iteration or per running through, this is going to check only once for the case statement. That's kind of strange. Okay, the number is 2. And then the default you have already known. When I put here a 3, then this is going to do that. Okay, so that's the default. Now this is that. Now there you can repeat a block of statements or a single statement by what is known as looping, right? So for example, I have a flag which says int x equal to 3. Now I just wanted to tell you, in the conditional statement, okay, need not in if statement, the condition need not be just a Boolean, which means 0 and 1. It can be any number other than 0, which will be regarded as true, and 0 will be regarded as false. Okay, so this is not the same case in C# where your Boolean would be a object which will be exactly checking for true and false, not 0 and 1. So that's another story. So let's say if x is equal to 3, then while x is less than, so let's put here a condition, while x is less than 2. Okay, so initial value I have given as 3, and while x is less than 2, then you do a block of statements here. You can say printf, I can say x is %d, and then here put a new line character and let it print something here as x only. Okay, so now what this is going to do is it's not going to execute even once, because the condition is checked at the beginning of the statement, and it says if x equal to 3, and if x is less than 2, which is not, then it will not do anything, right? So if I do start without debugging, so nothing comes in here, right? But if I do x equal to 0, then it is going to print x equal to 0. Now one thing is there, now x will always remain less than, x is 0, so 0 will always remain less than 2. So there has to be something to increment it here, right? So it will print 0, 1, 2. It will not even print 2. If I put a equal to, it will print 2. So 0, 1, 2 it will print, and then it will exit, right? So here I can check what it is left with. So I can say printf uh, x is %d and new line comma x. So the scope of x is the function, so x should retain its value, right? So it should, for example, it becomes 3, right? It becomes 3, and then it checks and say, no, I don't have to execute this. Then it will go and still print 3, right? So the final value would be 3. So let's do that. So x is 0, x is 1, x is 2, and x is 3. So the last x is 3 is not coming from the loop, but it is coming from the final statement over here. So basically this is what while is. Now if I was to use a different form of this loop, so I can do a do followed by a while, and here I can say while x is less than equal to 2. So I'm just going to take this one to the bottom and say x is less than equal to 2. Okay, so I'm starting with 3. Now in this case it is not going to check the condition till it have executed it once. So it is still going to put x equal to 3, and then it is going to exit, and when you come here it will still put x equal to 3 here, x equal to 4, sorry, here, because it prints 3 then increments it, so then it's going to print x equal to 4 here. So 3 and 4 would be printed here. So a do while basically runs, the condition is checked at the end of the loop, so that means that block of statement is executed anyway, right, irrespective of the condition for the first time. So let's do that. Okay, so it printed 3 and 4. So that just proves the point, right? Now if it was 0, then it will go up to printing x equal to 3, right, again, because it will do 0, then it will increment by 1, print 1, then increment to 2, then print 2, then increment to 3, right, and then print 3, and then when it exists it is going to, so increment to 2, so it is going to still print 3 2 times, right? So let's see what it does. Okay, it doesn't. So let's see how it happened. X took a value of 0 and printed 0. Then x took a value of 1 and then it printed that. X took a value of 2 and printed 2, incremented to 3 and did that. Now the final condition is with x equal to 3 it's not going to repeat, right? With x equal to 3 it is not going to repeat. So that's why the internal statement will not print 3, but rather the external statement will print 3. Okay, so that's how that output is this one, right? Okay, so this clears a do while loop. Now if you know at the start of at the start itself, if you know that how many iterations I need to do, then I could have used a for loop. For, I can say I is equal to 0. That's a starting condition. Now which is already done, right? I is less than 3, sorry, I less than 3, then I plus plus, and then I can say this, okay, so you, sorry, not I, it should be x, right? Sorry. Okay, so x equal to 0, this is optional because you have already initiated x equal to 0. You could have left this like this, it will still work. And then you can say printf and then you can say x is percentage d space new line character comma x, and that's the end of the story. Now here x is initialized to 0, so initialization statement is empty, right? It's done. And then at the end you can check the printf x is percentage d new line and x. Now here I want to tell you one thing. Okay, this one is going to print, let's say if I make this 3, so then this loop is it going to execute? So basically the condition is tested at the top of the loop while the increment is done at the bottom, so I do not expect this to execute at all. So it didn't execute at all, only the last statement is this one, which is outside the loop, which printed x is 3. Okay, now if I make x is 0, then it is going to iterate with x equal to 0. So this condition, the first statement is executed only once. Okay, now this is a blank statement, so doesn't matter, right? I could have done this also. Then I can say here x equal to 0. So this is a reassignment and it still works, right? Okay, so I can say start without debugging. So it's going to print x equal to 0, 1 and 2. Then when it increments to 3, then it's going to check first if x is less than 3. No, it is not. So it's not going to execute that. It's going to, the execution is going to pass on to print the 3 here. So that's all. That's why x equal to 0, 1, 2 and 3. Now let's try one thing more, that I can make this variable to be a local in scope. So if I do local in scope and say int x, then this x should not be available over here. Then this should give you an error because the x is outside the scope, right? X is outside the scope. So that's why it says it's not identified. So I can just do this. Now it should work. Okay, so the final statement is not there, x equal to 3. Now I could have done another assignment here, int y equal to 0 also. So multiple assignments, again I don't need a int here. I could have just said y equal to 0, is it? Yeah. So now there is still one statement. Okay, I could have done int x equal to 0, int y equal to 0. I can, or rather int x, int y, and then I can say here, I can reinitialize this, x equal to 0, comma y equal to 0. So this also works. So multiple statements are allowed in the first section of for loop. In the middle section of for loop here, where the condition is there, you are not allowed to have two statements here. It has to be a single statement. Similarly, increment here can also be 2 statements, right? So this will still work, right? So I can put here another statement here, which is going to print y, right? So y is percentage d y. So that makes sense. So now I am going to check for the, so it is only going to do up to 2, right? And then 3 is going to be printed here for x, but the y is still going to remain, y is also going to be incremented, right? So because this is executed at the end of the statement, so let's print this here also. Okay, so now let's execute that. Okay, so x is 0, y is 0, x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. So that's how you understood. But if I try to do a condition here, and I can put a condition like this, and I can say or rather and y is less than 2. So now it will not go up to 3, it will go up to 2 only, because this is going to dominate this, right? Okay, so this is going to turn false, and the loop will not execute beyond 2. So I'm going to say, so x is 0, y is 0, x is 1, y is 1, x is 2, y is 2. Because the y condition terminated it before the x reached 3, right? Okay, so it went through 0 and 1 only, and then 2 was printed by this following two statements. So this basically completes chapter 5 in C. Thanks. Chapter 6 in C is on functions. Chapter 6 in C is on functions, type definition, and enumeration. So let's get started with that. So I create an empty project. And here I create a new item. I call this as exploring functions. So explore functions.c, correct? And here I am going to hash include stdio.h. Right, and then here I just wanted to mention what is a function. Function is a block of statements which can be reused, and it is provided a name, right? For example, your int main is a function, and a function has got a return type, which is like in this case is int, but it can be a void also, but not with the main. So main is supposed to return an integer to the OS, indicating whether the main executed successfully. And usually you can put a return 0 at the end, or you can omit it, right? So here this means that the main is not going to receive anything, right? So this is so. Now if I was to use a function, it has to be declared beforehand. The signature of a function is basically the name of the function followed by a parenthesis, and in this parenthesis you are going to put the arguments which you are going to pass. So for example, let's say I want to do an integer, return an integer, and I just do a sum, and this function receives int a and int b, right? Int b, and here I am going to define the function as return a plus b, right? So this is a function definition. Okay, so now I'll be able to use that, and I can say printf. I can say here sum of %d placeholder and %d another placeholder is %d another placeholder and new space. So here I can say sum of So I want you to pass in two integers. So I'm just going to declare int a equal to 3, and then I can say int, I can say b equal to 5, right? So now the sum is going to be passed back, right? So I can say a comma b comma sum, and I can use inline because sum is going to return an integer and the placeholder is type d, right? So I can pass in here a comma b bracket close, and I can put this thing. Okay, so this is a valid function call here. You can see here. Now let's run this. Okay, so okay, sum of 3 and 5 is 8, so which is correct, right? Now let's try something else. Let's say I want to do return void. So this is not returning anything. So this statement has no meaning. And instead of printing over there, I am going to print over here, right? So I can say here printf, okay, and here I'm going to say uh, the same thing. So it is not returning anything right now, right? So let me just copy this, paste this over here, and I am going to display here a, b, and then I'm going to display here the sum, right? So basically it is just going to print the sum. Hang on a second. So okay, so I'm going to print a, b, and sum of a, b. So the way I have called it over here is incorrect because sum is not returning anything. So I cannot say c is equal to sum a comma b, right? This would be wrong because sum is not returning anything. So then in this case it should happen like this, right? Okay, so this is correct. Here it doesn't return anything, it just calls this function and the function prints this. Okay, now the thing to note here is that a is a local copy, b is a local copy for sum, while here a and b are the variables which belong to main. So if you do any changes to a and b inside here, they are not going to change over here. So this is the next thing we are going to see. So let's first run this. So you see sum of 3 and 5 is 8. Okay, so this is fine. Now let's say that I want to return I don't want to return anything, but I want to return the value of a. In the value of a, I want to update as a sum, right? So instead of passing by value, I pass it by reference. So I'm going to pass a reference to a, right? And then here I am not going to do anything like that. What I'm going to do is so now a is passed by so here a is passed as a pointer, right? So I'm receiving a pointer. I can call this as just not to confuse as p. Then I can say the contents of p are going to be equal to so let me see if this works. Contents of p plus b. So if this is correct, then what's going to happen is that the P is going to receive that. So here I am going to pass the address of A, and here my sum will come in A. So I can say printf. Okay, so the A is updated now. Okay, so A doesn't store 3 anymore, it stores 8 here. So I can say here percentage sum of 3 and percentage D is percentage D. Okay, so what has happened is now I have lost the value of A, previous value of A, so I cannot put here A, that's why I put there 3. Then B I can put here, and then I can put here A, because A is not updated, right? Okay, so let's run this. Let's see if this works. Okay, so it says sum of 3 and 5 is 8. Now A is storing the value of 8 now. So the A is updated because here I passed on a pointer, right? So I passed on a pointer of A, and then whatever is the content of A, to that content B is added, and it is saved in the same location, okay, where A is stored, and so A is updated here. So that's how you pass by reference. Now what may happen is sometimes you may not be able to what happened? Okay, sometimes what may happen is you may not know all the functions in advance. So in that case, you create a signature for this, and then you can place it after main. Okay, so basically you can do this, but then you would have to do a declaration. So here there is a declaration, so that main knows that there is a function like this, and that declaration has to have a definition somewhere in the file, right? So that's what it has happened. So now the header files are nothing but similar declaration of functions. Okay, so now here this is perfectly fine. You have declared the function over here, you have used it in main, and then you have defined it over here. So this is supposed to work the same way. Okay, the sum of 3 and 5 is 8. So we have learned quite a few things over here. Now one more thing I want to mention is that I can pass on, so let's say I create another function which is called average. Okay, and this function basically is going to receive the number of inputs. So this is number of inputs, and then it is going to increase indefinite number of inputs, right? So here, okay, this basically is a parameter list which is depends on the call. You can include as many number of arguments as you like. In earlier versions of C, if you left this parenthesis empty, it meant the same thing. But now to be able to use this, I should be able to parse the argument list. So here I have to include another header file which is called stdarg.h, right? And then I'll be able to use that. So first of all, I have to define a list, right? So in that case, so here one more thing, I have to return the integer, right? Okay, so which will be the average of the entire thing, right? So here what I can do is I have to first generate a list. I have to declare a list here. Okay, VA list, and I call this as args. Okay, so this is a list. Okay, this is a data structure which stores all the arguments over here. Okay, and the thing is that when you declare something like this, you have to at least have one integer. You have to have at least one integer declared besides the parameter list, right? Okay, so now I can say int sum equal to 0. So here I'm going to sum all the numbers, and then I am going to say for, so I have to initiate the list. So I can say VA, sorry, so I have declared the argument list, but then I have to initiate the list. So for that there is another function called VA start, and that function is going to receive the argument list. So that is called args, and it is going to receive the number of elements in that argument list, right? Okay, so that's how you initialize the argument list. Okay, so then what you can do is you can do a for loop for int I equal to 0, then I say I less than num. Okay, so I less than num, and then I can say I plus plus, and here I have to say sum plus equal to I am going to parse that argument list with the index, right? So for that there is another function which is called VA arg, right? VA arg, and which is going to return me the integer value, right? So here I have to mention the list, which is args, comma the, I think it should be this. Let's see if this works. No. So I have to just tell the index type, I think. Okay. So that's the index type. So this is going to return the sum, and then I'm going to say sum divide by. Okay, so now divide by, so sum was equal to, okay, and here I have to, okay, so what is going to happen here is this is going to not return an integer, it is going to return a float, correct? Because the average can be a float, right? And then this, I can have the int as sum as int because it is receiving integer, but then I can pass it to float. Okay, so that I do a float division, and here I am going to mention sum divided by num. Okay, so what has happened over here? Just 1 second. I wanted to do an integer division here. This is still pointing to that. Must be an integer type. Sum. So can't I cast sum to float? Isn't it? Okay. What if this was a float to start with? Okay, now I don't have to do the casting. I can just do sum by num. So what has happened here? Okay, hang on a second. Okay, So the mistake I was doing was I was putting sum equal to. That's wrong, right? So I have to just do a sum by num. So now it is going to return a float, right? So here I can do printf, and I can put here a string which says average of three numbers. Okay, 3, 4, 5 is percentage f for float, new line character, and here it is going to return a float, right? So I'm going to call that function as average, and here I have to put in a number. So there are three numbers, and these three numbers are 3, 4, 5. Okay, so that makes sense. So now what I'm doing is I have just shown you how to. Okay, so one more thing is there. Once you have done uh, using the arguments, I have to deallocate the memory. So I have to call this function end, and then I have to pass here args. So basically there is a memory allocation and deallocation. When this list is created, memory is allocated, and at the end the memory is deallocated. Okay, so now this is complete. So let's here debug this. Okay, the average of three numbers 3, 4, 5 is 4. 5, 4, 9, 10, 11, 12 by 3, that's there. Let's give it a bigger list. Okay, so I'm going to call this as average of 4 numbers or 5 numbers. 5 numbers 3, 4, 5, 6, 2. 6, 2. Okay, so I can pass here 3, 4, 5, 6, 2. And how many numbers are there here? 5 numbers, right? So there are 5 arguments here. Okay, so now here I can debug. It says the average of these numbers is still 4. So let's see. 5, 4, 9. 9 plus 3 is 12. Plus 6 is 12 plus 6 is 18. Plus 2 is 20. And 20 divided by 5. So that is going to be 4. Okay. So that's correct. So this works. Okay, so next thing which I wanted to show was something called recursion. So where a function can call itself. So for example, let's say there is a function which is called fact. So it is going to return a factorial, and it's going to receive an input, let's say a, and so this is basically the definition, the declaration of a function. Okay, but there is no definition yet, so I'm going to put a definition below here. So I can call here printf, and here I can say so I can pass on b, right? So I can say factorial of percentage d okay, factorial of percentage d, and then is percentage d, and then I can put in here a new line function, a new line character, and then here I can say b, and I can call this function fact of b. So that's a valid call. Now here I'm going to declare a function which has recursion. So I can say int fact, okay, and that's going to receive int A, and then there is going to be a definition. Okay, so now here I can say if A equal to 1, right? So if A is equal to 1, then return 1. So there is no then, sorry. Okay. Else, so there is no question of else here. I can just say return, and I can call this function itself, but this time I am going to pass it a minus 1. So what's going to happen is on the last call, when a becomes 1, it is going to return 1, and then it will go back, right? So there's a problem here. It should be a multiplied by factorial of a minus 1, correct? And then factorial of 1 is 1, so that's going to be returned. Otherwise it is going to return this. Okay, so this being said, so this looks correct unless I have done some blunder. Okay, so factorial of 5 is 120. 5 into 4 is 20. 20 into 3 is 60. 60 into 2 is 120. 120 into 1 is 120. So that's what it has done. It has done a simple recursion here. Okay, so that's about functions. Now let's talk about type definition. Okay, sometimes what we want to do is, so I'm going to remove this all, and I'm going to remove this. Okay, sometimes what happens is we want to use basically we want to use a variable, but its type we have to declare again and again. So for example, let's say we deal with images, so we're dealing with bytes which are unsigned integers. So I can say type, so I can say type def, I can say unsigned int, unsigned, unsigned int as byte. So I have defined my own type. Now there is a problem here. Expect a. Okay, so there was a typing mistake here. Type def unsigned character is byte, and then I can say byte is equal to, let's say, 65. Right, you can store a value from 0 to 255, right? So I have to declare a byte, let's say a is equal to 65. So anywhere I can use this type definition here, right? But while printing, okay, let's see what happens while printing, right? I can go here and say printf, and here I should know the base type of byte. So a stores, okay, a stores percentage u, and let's say if this works. Okay, so I'm gonna run this, so I'm gonna put a new line here. So let's run this. A stores 65, correct? So type def works this way, that you can declare a type. So let's say I do a type def, and let's say I want to do a structure, and a structure basically is defined with the name, or I can just define it over here, and it has int, let's say num, right? And then I have to give a name to this structure as score, right? So I have called a score, so I can say score B comma C comma D. Okay, so I have created 3 different structures. Each one is storing a score, num, and let's say I can have as many fields over here, or what you call variables over here. So in a structure basically you can have variables. So we will cover structure later on. So now I can say b dot num is equal to 20, c dot num equal to 30, and d dot num. So this is a dereferencing operator. So this is going to access the variable or the field of a structure is 40, let's say. Okay, then I can say printf, okay, and I can put here number of elements in B is %d, and then I can say here b dot num, sorry. So that's a dereferencing operator, b dot num. Num is identified. Okay, so let's try to understand what has happened here. Okay, so just a typing mistake. So I am going to print that the number of elements in B is b dot num. Okay, debug, start without debugging. Okay, the number of elements in B is 20. So that makes sense, right? So number of elements in B is 20. Okay, so now we have seen how to use type definition. Okay, so the next thing I want to show you is something called enumeration, which is nothing but base type is integer, but then you give an alias to it or a name to it. So I can declare a enum, and type def, for example, can be a global or a local. Similarly, enum can be a global or a local. So I can say color, enum color, and here I can specify as red, blue, and green. Okay, so I can create here color x equal to, let's say, red. So have I done a mistake here? Color is undefined. Just 1 second. Okay, so I have to here specify that this is a enum. Okay, enum color x is red. Okay, then I can say switch, and then enum as a base type of integer, so I should be able to do here x, because this is a base type of case 0. So in this case it will be 0, right? So I can see here printf color is red, and then I can say brick. Okay, so here what happened, let's see, why doesn't it indent? Case 1 then I can say color is green. Color is green. And then the last one, sorry, color is blue, not green. And the last one is default. So which is the remaining case, the color is green. Okay, so I can put here the default case is color is green. Okay, so I have used what you call an enumeration which is local to the main. It could have been declared here as a global also, right? And here I have assigned this x this, right? So I'm going to do few more things. I could have said here, so let's just debug this first. So color is red. Okay, so let's put here 2 or 1. Okay, now it might give me a warning here because 1 is an integer type, even if the base type is integer, but I am trying to assign this to a enum or enumeration. So let's see if it gives me an error. Okay, it didn't. It might issue a warning, but it didn't. But it's a good practice to better cast it out and cast it out to color, isn't it? What mistake is that? Just 1 second. Okay, so cast it out if you are not in doubt. Okay, so I am going to run this again. So it says color is blue, right? So this is how enums are used, right? Now you can always mix integers with this. So for example, I can say x plus plus. So now it should refer to green, right? So let's see if it works. Debug. So the color is green. So you can use operators with enum assuming that they are integers because their base type is integer, right? It's better to cast them out whenever you do something like this, right? Okay, so this completes chapter 6 in C, right? Chapter 7 in C is about structures and unions. So let's make a chapter 7 in C project. Okay, so I'm going to study here two data structures. One is called structure, other is called union. Now, structure, unlike arrays, can store different types, different data types. And like, an array, you have same types which are indexed. But then array is by reference. So basically, when you have a declare array, the name of the array is basically a pointer to the first element in the array. Now, in case of structures, that's not so. It is by value. So basically, structure is passed by value. So let's make a new item and call this a study structure union. Study struct union dot c. Okay, so again, its scope can be global if you put it outside every function, right? And it can be local to a function. Okay, so let me just create a main. Okay, here let's declare a structure. So this is a keyword struct, sorry. Okay, struct, and then there is an identifier. So let's say employee. Okay, so I'm going to put all the data of an employee here, right? And then I am going to declare it over here as let's say it is going to have a array of characters, okay, which is called name, and I can give it a width, right? So let's give a width of 20, let's say, for example, right? And then I can have age, which can be an integer, right? So hang on a second, I'm doing mistakes here. Then I can have age, which can be an integer, correct? And I can have employee ID, which can again be an integer. So sorry, where did I put this? Okay, so that's a structure. Now if I want to assign a structure object, so I can instantiate the object right here itself before the semicolon, and I can say emp1 comma emp2, right? So I have created the structure, right? Now I can also say struct employee, okay, struct employee, and then I can say emp3. Okay, so now I have to, just like arrays, I have to fill them, right? So for example, emp1 dot, okay, name. Okay, so I can name this as, let's say, Ramesh. Okay, let's see what has happened here. Expression must be a modifiable al value. What did I? Okay, let's do the other one. emp1 dot age equal to 32. So there is no problem with the other one. Let's look at the employee ID. Okay, so I can say emp1 dot employee ID equal to, let's say, 0. Okay, so let's do character name, and let's not give it a this thing size. So that's fine. So now this is your first definition. Okay, second one is emp2, right? Now here I can say emp2 is same as emp1. Okay, so I have copied all the values of emp1 to emp2, but these two are different objects. How do I come to know that? So let's create a pointer p1 pointer to employee. Okay, and then I say p1 is equal to emp1. Correct. And then let's have another pointer, employee p2 equal to the location of emp2. Now let's try to print this. Okay, so I can say printf mem location of emp1 is, and then here I would say %d, right? And here I am going to put here not %d, it should be %p, and here I'm going to put the pointer, right? So that is going to be p1. So that's going to be the location of the first emp1 structure, object of that employee structure. Then I can say mem location of emp2 is %p space n comma p2. So now these are two different locations, right? So this is just I'm trying to prove that they are stored, they are referred by value. Okay, so let's try to run this. Okay, so these are two different locations, right? Okay, and okay, so I'm trying to see 24 and 38. These are hex values, right? Okay, and that would be the storage space of one structure. Okay, so now that I have proved to myself that they are two different objects, right? I can print their members or fields. So whatever is in here, name, age, employee ID, this is called members or fields of the structure. So I can do a printf, and here here I can say I want to print first employee is, right, and %\n, and then I can say p1 is a pointer, right? So I could have said the content of a pointer, sorry. So this would be the location, and then I can dereference it as name. So this would be basically, let me put in here a placeholder %s, because it's a string, right? So this is how I dereference from a pointer to a structure, right? And there's another way of doing this, is by using a lambda operator. Okay, so I can say second employee is %s. Then I can say this as a shorthand like this. So this also works. Great. So let's just run this. Okay, first employee is Ramesh, second employee is also Ramesh, right? Okay, so I guess you got my point. Then how do I access the member or the fields of a structure, right? So this is how you do that. Okay, now here this employee identifier is optional. But so in that case, if you remove this employee, then it can only be referred by the objects of the structure, because then the structure name is not provided. So the only way to instantiate an object for that structure would be doing on the same line, not like over here you can say structure employee emp3. You cannot say that, because then this employee is not available, right? So such structures are possible also where you do not have the identifier for a structure, but then they can only be instantiated on the same line, okay, where they are declared, right? And then you cannot do something like this. Okay, so now that we have done this, okay, let's see some other things while assigning. Okay, I can also assign so for example emp3 is left, so I can say emp3 is equal to, and then I can put in here just based on this I can say emp3, I can put here, let's say, name, and then I can put here another argument as age, as let's say this, and then I can say employee ID is 1. Okay, so is that correct? Expected an expression. Okay, is it? Now can't I just do emp equal to something? Hang on a second. Okay, well, you have to specify fully what emp3 is, otherwise it's not going to accept that. Okay, so now this is another way of doing this. Let's say the third employee is this, so I can say third employee is emp3 dot name. Okay, so here I can debug this. Okay, what's the problem? Okay, hang on a second. emp3 is now specified, right? So third employee emp3 dot name should not have a redefinition. Oh, redefinition where? Ah, this is a redefinition here. So in that case, it should allow me to do this, right? This is not a redefinition, right? But then this is pointing, expected an expression. Such an assignment is not possible, or what? Or do I have to do one by one? Dot name dot okay, doesn't matter. Okay, we will do another definition. So here third employee is that. Okay, now I can also do this. 4 is equal to struct employee, sorry, 4 is equal to, and then I can define it here itself. I can say Suresh, and then I can say here his age is 32 and ID is 2. Right? Okay, so this also works. I can instantiate an object like that. I can say fourth employee is emp4.name. Okay, so this also works. Okay, so we have created 4 structures. Now I can, okay, hang on a second. Okay, so over here I have created a 4th structure, and then this is by position that I have assigned the name, the age, and the ID. Okay, so now this is one way of doing this. Another way is, if I don't know the sequence, I can do but I just know the members, I can still do it. I can say structure employee emp5 is equal to, and here I can give the age first. I think they should allow me do that. Comma. I'm not sure if this is going to work. Let's say that, and then can I give an employee ID? ID is that and that. So here the sequence is not the same as the sequence over here, and let's see if it works. So I can say here 5th. Okay, so let's see if this has also worked. Okay, so that has also worked, right? So I need not do the assignment by position, but I can give a direct reference. Okay, so it need not follow this sequence. Okay, so this is how you create and instantiate an object. Now, how do you pass it to, if you want to pass an object to a function, then that, for example, I want to write a function here, right? And that function returns a void, and let's say ext extract. Okay, so that function is called extract, and this I am going to pass a structure, let's say emp, right? And just like to understand what is this. Unnamed prototype parameters not allowed when the body is present. Oh, okay. Okay. But then this scope of this structure is going to be, the scope of the structure is going to be local to main, right? If I take this out, put it over here, now the scope is global now, right? And these emp1 and emp2 are global, while emp3, 4, 5 are local. Okay, then can I do a void function name, and here it receives a structure employee, structure employee emp, and this is defined over here like this. Okay, so now this structure is global now, right? And then I can say, okay, let's do this. Let it return. So now this is passed by value. What I mean is that the 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 location of EMP is not going to be the location of what is being passed, right? So it is a new creation, right? So let's do this. Let's say structure employee, and this is a pointer to that employee, or rather I can just directly print it. Print. Now we know global emp1 is global, right? Printf. Then I can say here print mem location of employee 0 is %p new line n, and here I want to type here emp1 should be accessible name, sorry, emp1 ampersand. So location of emp1. Make sense? Yeah. And then I am going to say the same thing, which is going to be emp memory location of employee passed. So that's the employee structure which I have passed is ampersand emp. So now if I call here, mm, so it returns a void. So I can call here func, and here I can call emp1. So now what's happening is emp1 pointer. So function is going to receive a structure. This emp1 should be that, isn't it? Okay, so the scope was not matching here. This being global, let's see if the code is broken. Okay, let's run this. Okay, employee 0 is at this location, which is a global location here. Okay, it's a global, and then past is this location. So let me see, why can't I do this? Hmm. Why doesn't it accept emp1? What if I can cast it out? There's no casting which will work, is it? So the casting won't work here. So I'm not able to pass the global parameter. Okay, you are not able to pass global parameter because global parameter is already available, right? Right. So now here, this one, okay, global parameter cannot be passed because it's already available. So this makes no sense. The local one can be passed, right? Same problem will be with the apply to, right? It can be passed. Okay, so but with 3 it will be okay. So with 3 it's okay. Even I don't need to pass a pointer. Okay, so okay, so now what I do is the following. I pass on emp3 and I print emp3 here, and let me put on the location of emp3 before I pass it. So Control C. So here I'm going to print the location of emp3. Correct. So I first put the location of emp3 over here, print it, then pass it, and then within the function I'm going to print the location of emp3. And if they are passed by value, then these are going to be different locations, memory locations. Okay, so this is passed by value because these two locations are different. So this is a new copy. Okay, so that's what I wanted to prove. Now let's say if I pass this, so if I pass this by reference, okay, so in this case this would become, so this is passed by reference, so this is how it will be printed, right? The location is passed by reference here, and here I need to pass ampersand here is emp3. So now again, now these objects inside, the object inside here would be the same as this one because I have passed a pointer rather than just passing it by value. So here I can also print f, okay, name of past employee percentage s new line character, and then over here I can say emp name. Correct? Okay, so I'm going to pass it by reference, then the two locations are going to be same, and then I am going to print out one of the field members, and that field member is going to be myself, Anurag. Okay, let's see. Okay, so let's look at the last one. Okay, so now I have passed by reference, so now the two locations are the same, and I've printed the name of the third employee. Okay, so this is passing by value and passing by reference. Okay, so with this clear, okay, let me move on to few more things about structure, how you do the type def. Okay, so you see here, this is very annoying when you say structure employee everywhere, right? So one shorthand can be, you can do a type def. Okay, so here let's create another structure and call this as machine. Okay, and then this structure machine is going to have a machine ID and uh, its age. Let's do that. Just int uh, mac ID. Okay, int mac ID, and then int age. Okay, so that's that, and I define this as mac1 equal to, and then I can give machine ID as 0 and its age is 10 in years. So this is a 10-year-old machine. Okay, so I have done that. Okay, so I can define a type def, right? I can say type def, sorry, type def uh, mach machine is machine. Uh, okay, struct machine is machine with, let's say, capital M. Just keep them separate. Okay, so now I don't have to refer with the structure every place. So I can say machine, and then I can say mch2 is equal to, and then I can assign it, and say machine ID 1, which has been there for 20 years. Right, so now you see I don't have to do this struct machine, so I have done a type def, right? And I can print here, printf, okay, uh, machine 1 has been there for percentage %d percent and n, and here I can say mac1 dot age, right? And I can also do a printf. Okay, and I can say machine 2 has been there for mch2 dot age. Okay, so that also works. Okay, so this is a type definition with a structure, and then passing a pointer would also be not having a struct. I can just say machine and then the pointer to that machine and then the identifier over here. So that will be passing by reference. Okay, or I can just do machine and then mchp or machine passed. So that will be by value. So here, that's that. Now I also want to create a structure where I explain you what are bit fields. So bit fields are basically I'm going to use different portions of a data type, go bitwise to store something, right? So I can say here uh, let's give a, okay, let's give structure my bits. Okay, structure my bits, just one second. Okay, so I'm creating here a structure my bits, and here I want to have a unsigned shot, and that unsigned shot I have an identifier F1 takes 1 bit. Then in the same unsigned shot I have F2, which is again 1 bit, or rather 2 bits or 1 bit. Okay, doesn't matter. And then I can have an unsigned shot F3, which is going to take 10 bits. Okay, so the total required is 12 bits, right? And so that's it. And then let's create an object over here and say struct my bits b1. Okay, and then I can say b1 dot f1 is going to be 1 bit. Let's see if I can do that 1 bit as this. Is it possible? Yeah. Then I can say b1 dot f2 is 1. Yeah. And b1 dot f3 is going to be 0b. I don't know if that's going to work here. 1 0 1 1 0. That's 4 bits. 1 1 1. That's 8 bits. Then 1 0. That's 10 bits, isn't it? Okay. So you see, I have created a structure which is going to be stored in 12 bits, but then I'm assigning 16 because I am assigning unsigned shot. Right. So where is this used? Bit field. When you do embedded C and you want to keep the memory footprint very small, and each bit is controlling one pin, for example. So in that case, you might be using something called bit fields. So that's all about structures. Now let's do something about unions. So I'm just going to leave the program with just main, and I'm going to delete everything. Okay, so over here I'm going to talk about union. So union, and I can declare a union here as, now the difference between structure and union is structure is like cascaded, like, you know, first member field, second member, third member, and so on. So every member is pointing to a location, okay, where the structure is stored, a different location where that type is stored, that variable of that type is stored. But in case of union, irrespective of uh, irrespective of the member, okay, every member is going to be referred by the same location, which is the starting location. So basically you are reusing the memory, right? So for example, I can say union, uh, I can say COMP, compact memory, right? And I can define it like this, that I can have a character, and let's that character be nm, and it uses 4 bytes, correct? Then I can declare a short, okay, that would be uh, what can I say, L and G, for example, any name I give here, and here I am going to do two of them because each one is going to be 2 bytes, so this will be 4 bytes. Then I can do int, and I can say this int is going to be let's say a, doesn't matter. So now see that each one is the same size. This is 4 bytes, this one is going to be two of these 2 bytes, so that's 4 bytes, and this one is also 4 bytes. Then the net net size of this union is going to be 4 bytes. Okay, so now I can say un is assigned un dot let's say a is equal to 0x, this is going to be 4 bytes, right? Each byte is 2. So let's start with fa01. So that's 1 byte, that's 2 byte. Okay, 303 bytes, and ec. Okay, so now here fa is stored in, so I can say now what's going to happen is let's print it out. So I can say print f, I can say here percentage, so I'm going to say characters, right? So I'm going to read them out as characters, right? So printf first character, and then I would say percentage d, okay, and n, and here I can say un dot nm, sorry, un dot nm, and I'm going to read the 0th one. Okay, so the first character, so this is fa, so in decimal, so let's look at the calculator. So if I go to programming, and if I say hex, then I can say fa, so that fa is equivalent to 250. Okay, so let's say if it prints 250, so if I do debugging, oh, minus 20, because it has exceeded the value, right? So it's a signed number, right? So let's take another example then. Okay, how about if I change this to 0a? So now 0a should be equal to 10, right? So it should print 10, right? So that's fine, let's do that. Again, it is doing minus 20. Just 1 second, let's close this. Debug minus 20. Why is it doing minus 20? It's a 0a, that's the integer value, but what is stored in an 0, it's going to be 1 byte, which should be this, right? Oh, hang on a second. fa 0A. Debug. Oh, so you now understand. Okay. Okay. So it is starting at a base over here, not over here, right? So you see the base is going to be over here. So this is depends on the machine, right? Little Indian or big Indian, right? So whether it is referring from here, so it is referring here is 0A. I can call this as 0B, right? And if I run this, it will print 11, right? So 11. I can call it 1B. So this will be 16 plus 11, 25, right? So if I build that, 27. Let's see, understand that. Okay, so this is 16 plus 11. That's 27. Correct. So that's 27. So first character is 27. Then this is 30. So again, it's going to be a negative number, right? So I can print here, printf. Okay, second character. Okay, and I can do one more thing over here is I'm gonna cast it to, can I cast this to unsigned int? Let's see if this works. Debug. This should be 0. It should be 1. Sorry, it should be 1 here. And if I go here, start without debugging. Okay, it prints second character is 48. Why is it 48? Okay, because it's 16 into 3. 16 into 3 is 48, isn't it? So an equivalent would be 48, right? So you can understand this like this. So if I take 30, so if I put a hex 30, for example, hex 30 would be 48. That's decimal 48. So that's 30, right? So that's 48. Now, so I can always look at an unsigned number here. Now, if I want to see a short, so this is going to be a short, right? So I can printf. Okay, and here first short, and I am going to cast it out, unsigned short, and here I am going to read lng, and I'm going to use, sorry, un.lng, sorry, un.lng 0. Hang on a second. Dot lng, wait, dot lng, then I'm going to leave the 0th one. Okay, here I'm going to read 301b. Okay, so let's see what is 301b. Okay, so if I put here hex 301b, that is 12,315. Okay, so I'm going to start without debugging. 12315. So let's look at the calculator. Okay, 301b, that is 12315, and this is 12315. So that proves to me that I am using the same location, which starts at here, first byte. This is second byte, this is third byte, this is fourth byte. So integer is, so if I was to print the integer, for example, Okay, so first our integer is, and I say unsigned int, and I put here a. Okay, so now it will be all the bytes combined, 4 bytes combined, and this is fa01. Okay, I have kind of changed it right while typing it, fa01 1b30. So I just altered this. Hang on a second. Okay, so fine. So now I want to see what is the integer value. So it gives here unsigned int value is 419438185, right? 1851. Debug. Start without debugging. Okay, that's a negative value. Why there is a negative value printed? I did unsigned, isn't it? I casted it. I casted it to unsigned int, isn't it? Then this should convert to unsigned int. Should cast it. Let's do this again. Okay, doesn't matter. But you got the point, right? The point is, okay, let's do the following. Unsigned int, and I don't do the casting. Now, is it going to cry? Let's do a debug on this one. Still prints a negative number. Is it one byte, 2 byte, 3 byte, and 4 byte? So I have to just figure out why it's a negative number. Though I'm saying that this is an unsigned integer, right? Still printing it as signed. Anyways, so you got my point. The point is, I'm referring to the base location, which is the first byte, and irrespective of what is the data type, I'm using 4 bytes, and for 4 characters, it's going to use those 4 bytes, or 2 shots, it's going to use the same 4 bytes, or for 1 integer, it's going to use the same 4 bytes. So that's the idea of union. So with that, I complete chapter number. Chapter 8 in C is about type conversion, storage class, memory management, and command line arguments. So let's just get started with that. So let's create a new empty project, chapter 8 in C. So once you are done, let's create a new source file, add new item, and I would say study memory. .c. So here I'm going to do hash include stdio.h, and then I am going to have a main here. Okay, so let's talk about casting first. So what happens is, if you change the type or type conversion, if you change the type of a variable, right? Now that you can do only temporarily. So what is allocated is allocated. So for example, I can say int I is equal to 5, let's say, and then I can say float float, okay, k is equal to, then I can cast into a float and then assign this, right? If I was to say float L is equal to k, or rather int L is equal to k. So now this is a implicit conversion, like it's assuming that there is a floating point number which is stored in let's say 4 bytes, and it is allocated to integer, so the points or the decimals are truncated, so you lose data here, right? So this compiler would work with that. Okay, so let's put here some printf statements, right? So I can say printf, okay, value of k percentage f, okay, new line, and here I can put k. So I'm looking at the value of k, and then I'm looking the value of L. Printf value of L percentage D, new line character, and L. Okay, so this is referred to as narrowing, right? Because you have gone from storing a data which was wider, in the sense there was something after decimal, but then you lost it to an integer, right? Anyways, the L would be 5 because there was nothing here in L to start with. Okay, so there was nothing in k to start with, it was 0.00. So let's see. Okay, so it says the value of h, it should be k. Let me write this again. The value of k is going to be 5.00, right? So the value of k, so this is called widening, and I have casted the integer to a float, so it has widened it. And then I have directly assigned k to an integer where it has narrowed it on its own, right? So this works in C. Now the next thing is, let's say if I have two integers, right? In this case, let's say integer m is equal to 3, right? And if I was to say printf, so if I was to say int result is equal to I by m, okay, so in this case it will be 1, right? Because there will be no decimals, and this would be, the result would not be a float, right? So let's see what happens. Printf value of I by m. So this might go as a escape sequence, so I have to put that value of I by m is, and it will be percentage d because result is an integer, and I would look at that, and then I will also put a new line character here. So if I debug this, I'm going to see 1. So okay, so this is a divide by, right? So I'm little, okay, so this is not a escape sequence. Escape sequence is a backward slash. So let's do this again. Okay, I by m, I was 5, m is 3, is 1. So you see this is an integer and it is a implicit narrowing. Now if I want to avoid that, even if I did this, for example, float res2 is equal to I by m, okay, then also it will be 1. because it has not done the broadening on its own, because everything is an integer on the right hand side of the equation. So left hand side is also integer, and the division is integer division. So let's look at f raised 2. Okay, so now you might be expecting that this will be like 5 by 3, but it still be 1.000. So let's see. Okay, so it still says it's 1.000. Now how do I correct that? At least one of the parameters I have to widen it. So I can do here, cast it to float. Okay, so why can't I cast it to float? Okay, so I have casted it to float first and then divided by m. So now this will be an integer division. Sorry, it will be a floating point division, right? So it is not no longer an integer division. So it says 1.6667, right? So now here it is an implicit widening. So it has widened I. Okay, so this is explicit widening, but then it has done this m as a widened m as 3.00 before dividing it. So you understood that this is the explicit way of doing this. So narrowing and widening can be implicit, as in case of expressions, it is widening is implicit here for m, and it is narrowing is implicit over here when L is a sign value of k, right? So this you have to be careful about. Now you can also cast pointers, so that we will talk later on. So I will, when I talk about memory management, then I'll talk about casting the pointers. So this is about casting, right? So same thing in case of a enumeration. Okay, integer and enumeration, you can cast it out, right? Okay, now this is about typecasting. Now let's talk about memory management. So memory is allocated in RAM in what is called the memory layout, right? Now this has an address. Now memory is also present, so there is a stack defined in the memory layout of a processor, and that stack has a stack pointer and a program counter and stuff like that. No, sorry, a stack pointer, sorry, not a program counter. A stack pointer it has, which points to the memory which is latest written into it. So most of the allocation is going to the stack, but then you can also tell whether a certain variable which is very frequently read can be written into a register of a processor. Now the register doesn't have a address, so basically then it doesn't have a pointer, right? While the stack has a stack pointer, right? So that's the stack memory. Besides that memory, there's something called heap, and that heap memory has to be allocated and delocated by the user, right? So there are certain functions which are in the include std lib file, okay, stdlib.h, which are like malloc, calloc, malloc, realloc, and free. So these are some of the functions which are available in stdlib.h. Now let's use that. So when you assign a memory onto a heap, it is usually done in blocks, and you specify the size of the blocks. So for example, I can return a pointer to a character, call this as pointer to a character, and then I can say malloc, sorry, okay. Then here I have to give the size. So let's say the size of a character, so I can use size of, and I can here specify character, and let's say how many characters. Let's say I want to do 5 characters. Okay, so now this returns a pointer PTS, which is allocated a block of 5 bytes, right? Now you can write this using this PTS only. So you can say the content of PTS, okay, is equal to, let's say, A. So in this case the character A. Then I can say the content of PTS plus 1 is equal to B. Okay, now mind you that PTS is not updated here. It's just that I am offsetting it by 1, 2, 3, 4, right? Okay, so I would have 5 allocations like that. Then I can say PTS plus 2, okay, equal to character C. Then I can say PTS plus 3, okay, is equal to D. Okay, and then the last character I can say PTS plus 4 is equal to, let's say, a null character. Okay, so I have stored A, B, C, D in this. Now let's say if I can print this, print F, I may succeed in this. My string is, and this is immutable. Immutable means that you cannot make changes to the size, but you can cast them, but you cannot make the changes to the size. And you have, if you want to create, you have to delocate it and then relocate it, right? So let's say my string is %s. I'm not sure if this is going to print, but I'm going to try it, and I am going to say the string is pointed by PTS. Let's see if this works. Okay, so if I go here and start building, okay, I should have freed the memory also. Okay, I didn't free the memory. That's wrong. So once you are done with this, you are responsible for all the memories, right? So here you have to say free PTS, and then you have to also set the pointer PTS to null. Okay, so that's how you have properly deallocated the memory. So let's do that. Okay, so my string is ABCD. This is what it is being written here. Okay, so strings are immutable because of this, because they are allocated in the heap and they are pointed. Now if I want to change this string to be a 6-character string, okay, I wouldn't be able to do that unless I relocate it. So I have to give here a new pointer, okay, new PTS, and then I have to say realloc or reallocate, and then I have to specify here the pointer which was previous pointer. Then I have to give the new size. Okay, so the new size here would be let's say 6 character. Okay, so that will be size of character into 6, right? So it will be now 6 characters, but then you would have to say PTS is assigned okay, so this might succeed, might not succeed, right? So even this allocation might succeed, might not succeed, right? So anytime when you do this, it's a good idea to say if PTS not equal to null. Sorry. not equal to null, then you do this block. So basically I can do this accessing inside here. Okay, and also I should do this inside here. Okay, so if PTS is null, don't do all this, right? But if PTS is not null, then you can do this. And again, I will take these also inside. Okay, and now here I was doing relocation, right? Now this relocation may also succeed or may not succeed, right? So if, okay, so here I have freed this, so I am not freeing this here. Control X. I'm going to do this at the very end here. Okay, so if new pointer not equal to null, then you do something. Okay, so now it's a relocation, right? So this I will remove from here. Okay, so now what's going to happen is I'm going to make this 6 character, right? So I'm going to just copy this. Okay, hang on a second. Okay, so now here I can, so if this is not equal to null, then first thing I have to do is I have to allocate, I can use new PTS, the pointer back to the freed pointer. And second thing is that the block is freed by relocation. The previous block which was pointed by PTS is going to be freed by reallocation. But then the pointer is still pointing, so now that pointer which is updated over here, right? Now I can do the same stuff over here, but then I can add one more, which is going to be PTS plus 4 equal to E, and then PTS plus 5 is equal to null. And then I can printf that statement. Control C, Control V. Okay, so I can print this statement, and my new string, new string is this. Okay, and at the end I'm going to free the pointer. I'm going to free the memory pointed by PTS, and then I'm going to set the pointer to null. So this way I have not caused any memory leak. So let's see. Okay, so my string is ABCD, my new string is ABCDE. Now this is what happening under the hood in some of the languages like C# or Java, where you say string is immutable, which means that string, if you have to resize the string, now string is allocated not on the stack but on the heap and has a pointer and as a block size. So if you want to expand the string, okay, so you would have to do this this manually. If you were to do, it will look like this. Okay, so in other case string is recreated and a new pointer is specified. Now over here I can do one more thing. Okay, I can cast Okay, so this is going to be 6. Okay, so now I can go back to set it back to the original size. So I'll have to do that again. Okay, so here I have to say new string. I will go back to 5 here, right? And then if new pointer is not null, then I would have to do this. Okay, so when you do string copy, string concatenate, under the hood a new string is created. So that's what is happening in std uh, in the strings.h, right? So here I have relocated 5, and this would be called null then. And this will be gone. Okay, so this is my newest string. Let's say, okay, and let's this run again. Okay, again I have freed the pointer and this. Okay, so let's do this. Okay, so where did it go wrong? Hmm. It says redefinition, multiple initialization. Ah, okay, new PTS is still there, right? So as soon as I do this, I should do new PTS to null. Yeah, then I don't have to do this. I can say new PTS is this. Let's say, okay, fine. So there was a redefinition. Okay, my newest string is back to ABCD. Now I can show you one more thing. I can I cast this? So what I'm going to do is I'm going to say pointer to integer. Okay, and no, I will even reduce this to 4. So hang on a second. So this will be 4, correct? And let's move the null to here. Now there are 4 bytes in this, and what's the problem here? Expected, oh, so I started casting. So let me test this again. Okay, so it will be ABC only. Okay, fine. And the last one is the null character. Now I can typecast it. Okay, so I can say int, and I will say uh, int pt, okay, is equal to casting to pointer to integer pts. Okay, and what happened? Just 1 second. Let me also set this to null. Okay, now what is happening? It is unbalanced. pointer to an integer is equal to casting just a second. Okay, so this casting is not allowed. That's what I was trying to say. So once you have done this and said that this is a pointer to a character, this casting is not allowed. Now if you were to do okay, so you can do this void new PTS, and here I would say 2, and then I'm allocating 4 bytes, and this is a void pointer, and okay, so here new PTS2 can be casted to pointer to a character. So character pointer, sorry. And new PTS2 equal to null. New PTS2 not equal to null. And PTS, and here, sorry about that. So let's see this works, but then in this case I would have to cast this here before I use it. Okay, no, it is already casted, then assign, because this is a pointer to a character only, right? PTS is a pointer to a character which is reassign. Okay, so now if I run this, okay, so the void pointer is basically a pointer which can be casted. So I can say integer pointer to integer int PTS is equal to casting it out. So okay, so here I don't do a null here. Okay, so I can cast it to integer pointer new PTS2. Okay, so now there are 4 bytes, but then okay, so let me remove that also. Okay, so now there are 4 bytes, let's say A, B, C, D. Null would come as a 0, right? So I'm not going to use that. So I have casted the void pointer to a integer pointer, and here I've casted void pointer to a character, pointer to a character, and then assign A, B, C, D. Now I'm going to read it as that. So I can say print f, and I can say here stored integer is, and here I can say %d and a new line character, and here I can say the contents of int PTS, okay, and that, okay, and after I have done this, okay, so the storage is still character pointer. Here this is an integer pointer, and this is going to work. But then there are two pointers which I have to free at the end. Okay, one of the pointer remains to be new pts2 equal to null, and then the integer pointer is int pts is equal to null. Okay, because this is an integer pointer, it says I cannot assign null. Then how do I free that? Null should be 0.0000 should be 0, right? int pts is equal to, can I not do this? I could, right? Okay, so now if I debug this, hopefully it doesn't throw an error. Okay, the stored integer is 16842344849. So there are 4 bytes here. Okay, so A is 97, integer 97. So you can look in hex what this is. Then this is 98, this is 99, this is 100. So let's go to calculate. Right. So let's go to programming calculator. Okay, so I'm going to, I have this one is 97, right? 97. Okay, so then that is 61. Okay, so I'm going to note somewhere 61. Okay, where? So I'm going to put here 61. Okay, the next one is going to be 98. That's 62. Okay, so I have to just do this simply as 61, 62, 63, 64. Let's do that. 61, 62, 63, 64. Now let's say I enter a hex. Okay, clear. 61, 62, 63, and 64. So decimal is this, and it will not match because I have done reverse order. Let's look here. Is it? It is 168,423,849. So it doesn't match, right? So let's look at the other way of doing this. Let's clear this. So 64 plus first, 64, 63, 62, 61. So now it matches, right? So the base is going to be on the right hand side because this is depends on the Indianness, right? So 1684234. So let's say what it displays. It says 1684234,849. So that matches, right? So now I have written it as a characters, but read it as integer by using a void pointer and casting. So this is how you handle memory. Now let's look at, so let's get rid of all this stuff. Okay, so now let's look at, so that was typecasting and memory allocation. Let's look at the storage class. Okay, so whenever I have so there are, so I'm going to just write them over here. Okay, so there's something called auto, and that auto means if you specify auto or don't specify auto, that's going to be treated as auto as as long as, so it is auto means it is local to uh, a, a function. So that means that its scope is within a block, right? And its lifetime is within a block. Is lifetime is the block time, right? Whatever that is. Okay, then besides that there is something called static. Okay, so static would be, a scope would be local, okay, and lifetime will be same as global, or as long as main thread exists. Okay, so this is the lifetime of it. But then static has another property, that it is local to compilation unit. So that means that if a global is so that is, if global is static, it cannot be referred by extern in another compilation unit. Okay, so that means that it becomes local to the compilation unit. So that is what a static is, right? The next one is going to be register. Now that is deprecated because the compiler optimizes where it has to place a variable. You do not have to tell the compiler that put it in the register. But in case you do that, okay, then it has to save it in the register of a microprocessor, but then it's still under the control of the compiler. It may not. So let's say, how do I do that? So I can say, I can declare another function here, and I can say it returns a int, and this is sum, and it receives integer a, integer b, and then it returns a plus b, right? So this is my declaration of sum. Okay, now I can declare, instead I can declare something like, so I can declare an internal variable which is called s. So I can say int s equal to a plus b, and then I can return s. Okay, so this would be an auto. Even if you don't declare it as an auto, it will still be auto. So s will not be accessible as soon as this is exited. It is just not there. Now one more thing I can do, I can say so this is very simple. Then I can call here int a is equal to 3. Then I can say int b is equal to 4. Then I can say print f. Okay, then I can say sum of percentage d, and percentage d is percentage d and a new line character, and then I can give here a comma b, then comma, if I was to do s will not be available because s is local to sum, right? So in this case I would have to say sum, and then I have to pass on this 2, which is going to be a comma b, and that's it. Okay, so if I do that, hmm, okay, sum of 3 and 4 is 7. That's done. Now, so there is no way that S is going to be accessible outside. Now, what I can do is I can put here integer and say count, and it is going to receive nothing. So I'm going to say void, and here I am going to say static cnt is equal to static cnt equal to 0, and then I can say cnt plus plus, and then I can say printf. Again, cnt is local, so its scope is within count, the function count. It is not outside. So from main, I cannot refer to cnt. So I can say printf, and I can say here current count is %d, comma, and that is cnt. Okay, now I have put here a way to return it. Okay, so int would be returning the current count. Okay, so that works. So the way to access this would be to return it. Okay, so now this is static. Okay, it will be initialized only once. So this is going to be ignored for the second call. It is going to, the execution will start from count plus plus, right? So if I was to do here, okay, I think I could just skip this because I don't want it to be available outside. So I could have just said void here. Okay, fine. So that's fine. So now here I can say count and call it once. Okay, so if I debug this, why is it so slow? Okay, count is 1. Current count is 1. Okay, so now let's call this 2 times. Count. Now the scope, the lifespan is the main. So when the main thread exists, then this would be destroyed. So if I was to run the program again, it will not say 2. Okay, it will still say 1 if I had 1 call. Now if I had 2 calls, then it'll do increment. Okay, so count is 1, so I forgot to put the new line character here. Okay, let's run this again just to avoid confusion. Okay, so now you see that current count is 1, and then the next call caused the count to increment to 2, right? Now if it was not static, what will happen? So if it was not static, okay, and it will be reinitialized, right? So every time I call it, it will be 1 only. Okay, there is some error. Count undeclared identifier. Okay, sorry. I removed that also. Okay, now. So you see, it is not incremented. Every time it exited the block, it caused this to be delocated memory and count was lost. And the next time when you approached it, it was again initiated to 0, incremented to 1, and then printed here. So now you can see that static basically means that its lifespan is as long as main is there, right? So that's there. Now once you are clear with static, there is something called register, right? So I could have called this as register int. Now it is up to the compiler to do anything with this. You won't see a difference. It still be 1 1. Only thing is that for a microprocessor, the access time would be reduced because it is now stored in a register. Now there is no way I can show you that, right? Okay, so that's that. Now what happens is, usually the reverse side of this is going to be called volatile. Okay, so what it means is that this int count, you have to check back wherever it was stored as soon as it is entered. So what happens is, to make the programs run fast, the compiler may take a variable and put it inside a register. Now, so because it is frequently accessed. Now, to make sure that even if it is stored in a register, the compiler is supposed to check the value of it, because the registered can be assigned through an interrupt, right? So if I cause an interrupt to a microcontroller and then change the register value for a microcontroller, now that register value is changed, right? So it has to know that. So rather it is telling the compiler, don't take it to the register, because it has to be checked every time it is being accessed, right? So the interrupts are the ones which can change it, right? So that's done. Okay, so now the next thing I want to show you is, so that is register volatile. Then so register is forcing a variable to be stored in microprocessor register. Okay, it has no pointer. Okay, so with that is there. Volatile is forcing a variable not to be stored in register. So that's the reverse of it. Now then there is something called extern. So extern is used for referring to global variables from another compilation unit. Okay, so that means that like for example, what happens with functions. Okay, so functions may be in the libraries, which is a external compilation unit, right? So if you want to refer to any global variable over there, I could have put here as extern, and then I can say int, and then the name of the global variable, which I don't know here. You might know it if you look at the header files. What are the global variables available in stdio.h? What are the global variables available in that library? And then you can put that here, access it. Now had they been static over there, then you would not be able to access that. So that's what an extern is, right? And anything you assign here is static, global. So if it is global and it is static, then that's not available outside the compilation unit. And same is true with the functions. So far I can say static int main. That means that the main will not be accessible from outside the compilation unit. So that's what it means. Okay, so I can declare all my functions to be static. That means that they will be available only in this compilation unit. And static has a very different meaning when it comes to classes and objects, right? So that we are not going to talk here. Okay, so now that is what an extern is, right? And other than that, there is another thing which is called constant. So let's get rid of all this. Okay, let's get rid of all this. Okay, so now I'm going to talk about constants. Okay, so constants, so when I declare some constant, so for example I can declare int const a equal to 5. So the only way I can assign a is here in the same statement, otherwise it will not let me change the value of a, right? I can also say constant int b equal to 6. So both ways are working. So these are constant values, right? And I can also pass a constant to a function, right? Okay, so the the pointers to these constants, right? For example, I can say constant uh, int uh, sorry int pointer p is equal to ampersand a. Okay, so this would be a constant pointer. Okay, so that means, so this would be wrong actually. So I have to declare here why it will be wrong. I'll tell you. I'll say c is equal to, let's say, 4. So now I can say c. Okay, so a pointer, a constant pointer to c. Now the pointer cannot be changed. Now if I was to say here a, then I have to call this as, the value is also constant, const. So the value is also constant. So constant pointers are not, pointers to the constants are not handled the same way as the pointers to the variables, right? So don't mix them. Okay, so constant to a pointer has to be a constant, right? A pointer to a variable can be a constant, right? So that's clear. Now again, the assignment, for example, I can say uh, do I say volatile int d equal to 5. Then I can also say int volatile e equal to 6. So either the sequence can be either, but the sequence with constant, you have to be clear. One is referring to a constant pointer, and the other is saying that the pointed value is a constant too, right? So don't mix the 2 pointers here. So that's about constants, right? Okay, so that completes chapter 8 in C. Chapter 9 in C is about topics which I have just missed out in various other topics, and also about the preprocessor or processor directives, right? So let's do a chapter 9 in C. That's an empty project, and here I'm going to add a source file as a new item and call this as what do I want to call it, miscellaneous .c. Okay, so here first of all I'm going to talk about inline functions. So I do a hash include, and here I do a std io.h, right? And then here I define int main void, and here I can call a function, right? So now the problem with the function call is the following. whenever you call a function and it is executing something, right? It is going to stop wherever the execution is. Place everything onto a stack, and a stack is like a memory map for a processor, right? And there is a well-defined stack which is of a certain size. So as soon as you do that, it is going to take all the registers of a microcontroller, place it onto a stack and stuff like that, right? Now whenever you call a function, that's going to be an overhead. And when you call a recursive function, this overhead is a lot, because you every time you are making a call to a function itself, right? As we have seen earlier in recursion. Now these problems on memory side, the stack related problems, can be kind of eased with something called inline functions. So what I have to do is I have to just add inline, correct? And then let's say int sum is the remaining function is going to be the same, right? Int a comma int b, right? And that function is going to do return, and it is going to return a plus b, right? So that's declared as an inline function. Now that's different, because whenever it encounters sum, okay, in the program, it's going to replace this by this text, which is like a function is being defined, right? But then it is the memory, it is more efficient, because you are not writing to the stack. Okay, so I can say int a equal to 5, then int b is equal to, let's say, 6. Then I can say printf, and then I can say sum of %d, and %d is %d and a new line character. And then I can say here a comma b comma sum of a comma b. So this is going to be a call to a inline function, right? So let's debug this. It's going to look the same. Okay, the sum of 5 and 6 is 11, right? So to you it doesn't make a difference, but then it makes a lot of difference when you have lots of function calls. So that's about the inline function. Okay, sometimes what may happen is that user may pass on some information to the exe file which is already precompiled, but then there are certain variables it can pass on from the command line. So basically, if you were to compile this and then execute from the command line, you should be able to pass some arguments to it. Then you can do this, okay, and you can receive certain arguments from the command line in an array like this, right? Okay, what's the problem here? Expected an expression. Okay, so now at least one argument is passed, because I'm going to compile from within the IDE. If you were to compile from the command line, you could be able to pass on more argument, and at least one argument would be passed, right? So here let's try to see what is the 0 argument, which would be most probably the file name which I'm trying to compile or trying to run, right? So in this case, at least one argument is received, right? And then I can put here a new line, and then I can say %s, and I can look at argv 0 element. That's it. So most probably it will give you the exe file it's going to run. So let's do this. Okay, at least one argument is received, and that argument is user nigam source wrapper where this file is, and that's the exe file, right? So that's what it's received, right? So this is about the command line arguments. Now the next thing I'm going to talk about is going to be so let's not do that. Let's talk about preprocessor directives. So for example, when I do a hash include, right, so that hash include is going to include a file which is a header file. Now this header file is a text file, same as this code file which has extension of .c, right? There is going to be a header file, right, which is in this case is these header files. Okay, so now header files are just the function declarations or type defs or variables which are going to be shared, like external variables and stuff like that. Okay, so that's a header file. Now if I want to use and another implementation, so if instead of, so let's say if I have another file here which says miscellaneous2.c, and if I want to use that, then I could include either I write the declarations for the functions over here before using it, or I would have to make a separate header file for all the functions which are in mis.c and then include them as a header here, right? So that's include. Now here this angular brackets over here indicate that you start searching from a predefined path which stores all the header files, or from the root directory, right? Now in case I have my own header file, I would basically place them in double quotes, and that says that please start looking for this file, okay, from the current directory, right? Or I can even specify the entire path over here, right? I can specify the entire path where that file is, right? So that's about hash include. So in this case I have stdio stdio.h. Okay, so okay, fine. So now, so this is for including the files. There are other preprocessor directives, like for example I can define a variable, right? So I can say hash define, okay, or all small, maybe hash define, and then I can define a variable pi. Let's say, now in this case there is no requirement for a semicolon, and let's say 3.14. Now okay, so I'm using this. So anything over here which starts with hash define or hash something, this is called a macro, or it's a preprocessor directive, or it's a text which basically is instruction to a compiler what to do, right? So in this case I'm telling that declare a variable, a pi, which is this much, and then I can do the following. I can say a is equal to pi. Okay, now the problem is it's going to truncate. So I can call this as a float, but then the problem is I cannot call this function. Just 1 second. Okay, so let's try to understand what this is. Okay, just a second. Okay, so you do not need a equal to over here, and that was the reason why it was not accepting BC. Okay, so now here I can do pi, and their pi value can be 3.14, and here I can put pi because this is a text replacement, right? For example, if I was to do this and do this, this will work too because it's going to replace this with this text, right? So that equal to appears twice, right? So that's the problem here. So now, having said that, I should be able to run this. Okay, so sum of 3.14 and 6.5 is going to be 9.64. So that's correct. So that's with the hash define. Okay, now let's say that this was defined somewhere else in another header file. Now, redefining it would be a problem. So there are two ways to handle this. You can say undefined, right? So you can say undefine this. Okay, so let's say the pi was declared earlier before that. Then I can say hash udef undefined pi, and then I'll be able to define it again, right? Hash define pi, and this time let's give it another value. Let's say 5.25. So okay, so now I've undefined pi and then redefined it. So let's do that. Okay, so now 5.25 plus this is equal to this. So this is correct. Now there is another way of handling this. You can say if if uh, not defined. So if pi is not defined, then define this, and then you can say hash and if. Okay, so if the pi was not defined earlier, then it will define it. So that's another way of handling this. So this time it will take a value of 3.14. So if I debug this, okay, so now it's going to take 3.14, right? Now if this was not there, for example, then the pi is not defined earlier, right? So if it is not in the header file, it's not defined. So in this case, it will take the new value. Okay, so that's if not defined, and if defined, and if defined, and if not defined. So if defined is also valid. So if pi defined, so let's define this pi. Sorry. So if I define pi here to be 3.14, then I can say if defined pi, then undefined. So undefined pi and give it a new value. So I can say udef. Okay, you can do a undefined pi, and then you can define pi again. Define pi to be 5.25. So the pi was defined. So if it is defined, then undefine it and define a new value. So this is again going to work. It's going to take 5.25. right? So that's correct. So now you can also write a if then else statement, right? If else, if else if, so if define then undefine this, then you can say else, you can say else. So let's say if it is, so you can say else hash define pi as 3.14. Okay, so let's see what is it. Define is this. If define, so if it is defined, yes. So undefined pi and redefine the value. Else define is at 3.14. So first condition is already checked, right? So in this case, it's going to redefine to 3.25. And it issued me error. So else, let me check. Else option, there is a issue here. Okay, so now it has taken, if it is not defined, it has taken that value. Let's see what happened wrong here. I can do a hash define pi and give it a value of 3.14. So if pi is defined, then it is going to undefine and then it's going to receive that. So there is a problem here. Is there? No, there is not. Okay, so there may be typing error. Okay, so sum of 5.25. So if pi is defined, then undefine it and redefine with a new value. Okay, else, so if I remove this definition, then it's going to follow the else path, and it shows that it is highlighted now, so it's going to follow that. So now it's going to take 3.14. Okay, so that's how this if, and then you can have multiple else ifs, right? Multiple else ifs are there, so you are going to write here hash elif. Okay, else has so if it is not defined, so if it is defined, then follow this. Else if there's only one function that it is defined, right? Okay, so I have to put here something. Else if so if it is not defined, then it's going to go to else if something else, right? So that's how else if is used. So I don't have a example in mind right now. Okay, so you understood how to write if, else, and if. Okay, another thing is that there are some predefined macros, right, which give you information about the file which is being compiled, right? So let's look at some predefined macros here. Okay, so these predefined macros I'm going to list, right? So I'm going to list these predefined macros in here. Okay, so here, so some of the predefined macros are file. So if I say something like this, okay, so it is going to mention the current file, path of the current file. So I can print here, so I can print here printf currently compiled file is space, and then I do percentage s and a new line character, and here I can put here file. So let's see if capital file is available. Okay, so this is going to be that. Yeah, so it is going to be double underscore. Sorry. So now I'll be able to do that. Now here there is a pi which I missed, so let me put back the pi. Hash define pi 3.14. Okay, so that's fine. So let's run this. Okay, currently compiled file is this location. So this is the currently compiled file. Okay, and I can also print in the line which is being compiled. Sorry. So currently compiled, or rather currently executed line, is it? So this is for the debugging information, right? So currently compiled line. So this is where I am. Then I can say line. Oh, sorry about that. Okay, so now I would run this again. Okay, there is a warning here. Printf. Okay, it has to be a number. That's why there is a warning. So a line number is there. This should not be %s. It should be %d. Okay, it has done. Okay, it cannot pick up the line number. It cannot pick up the line number. The line has to be a number, isn't it? Hmm. Let's do this. Let's do a build and see the error. It didn't have a build error, but it has a runtime error. Double to float. Okay, so this is a double to float. This is a warning here. And I don't see here a problem of what this is going to be. Right? Let's see what the error says. Okay, let's do this again. Debug, start without debugging. Okay, so the currently compiled line is 12. Yeah, so this is the 12th line here. So I can basically send in information that if I want to debug something, I can send some kind of a trace from here. What is being there. So the other one is the date, time, function, and which function name it is in problem, right? Which function it's working on. So it's going to be a string for a function, string for a date, time, and then it can be, yeah, so it can be that. So other than that, the preprocessor directives are going to be error. So in case of a error, I want to print a certain line, right? So I can do that. Okay, so I can do a error. So if I do a mistake, then it is going to type that. So let's remove that. So I can do a hash error. So error is going to stop the operations, and I can put this in your double quotes. I can say compile error. So is that okay? Hash error, compilation aborted or compilation error, hash error directive. Why didn't it accept it? Hmm. So error is not available, or maybe I'm typing it wrong. Now the other one which is left is called the pragmatic information. Okay, so here, okay, so let's try that. PRAGM. So pragmatic, PRAGMA, PRAGMA. Sorry. Compile error, and then this error can be in a certain line number, right? So for example, I can put here it is in certain file, so I can put here the file, and then I can put here the line number, isn't it? Right, and let's do a error by introducing an error. So is that an error? Yeah. So let's try to start debugging it. There was a build error. Okay, how do I catch that? There's a build error here. What should be the problem? Okay, there is no error here, so how do I throw this exception that will give me a pragmatic information? Does it give me a pragmatic information anywhere? Uh, or I can say compiling so file number. So I cannot give an error, so it should at least give me what it is compiling, right? Pragma message compiling file. No information. Okay. Does it give somewhere here? Debug, start without debugging. Okay, now let's do this. Debug, start without debugging. This is line number 4. Warning, expected this found a string. So I'm wrongly using this. Okay, so I'm wrongly using this. Okay, but anyways, so you can learn on your own what is this pragma, and as long as you're doing debugging, you will be able to throw these messages. So I'm gonna stop here in chapter 9. Thanks a lot. Okay, chapter 10 in C is about headers and how to distribute the code into files, or how to organize your code into different files in the same project. So I can call this as chapter 10 in C. Right, so here, first of all, I'm going to add a file which doesn't have an entry point as main. So it will be implemented into another library called library rather than an executable. So I'll add a new item and I will call this as mathfunc. So all math functions I'm going to keep here, right? So I can say add, and here I can do a hash include, and here I'm going to include stdio.h. Okay, the next thing is I'm going to define some functions here. Okay, so let's say the function returns a int and it is sum, and it receives two arguments, int a comma int b, and the implementation is as good as a single statement return a plus b, right? So okay, so there is a problem of space here. Okay, so now that's one function. Then another function is similar to this, which is called difference. So I call this as diff, and I will say a minus b. Then I can do another function which is called multiply. So I will call this as mul, and here I can return a into b. So now there is no entry point here, so basically this file cannot be run because it's not going to be executable. Now next is I am going to make use of this. So I'm going to add a new item here, and I would say use library, use lib, because I'm going to use a library. Okay, so this is another C, this thing. Here also I do hash include, right? And here I am going to say stdio.h, correct? And then here I'm going to have a main entry point, int main, which receives a void, and then I am going to make use of the sum function. But before I do that, I would have to declare it here, what that function is. So that function is a sum, and its signature is it receives a and then it receives a b. So that's the function declaration, not a definition. Definition is in mathfunc, but then before I use it I have to do that. Then I can say printf, okay, and I can say sum of %d, and %d is %d and new line character. So here I can do a b, and then sum of a comma b. Now I haven't defined a b yet, so that's why it's going to give you some errors. So I would say int a equal to 3, and then I can say int b equal to 4, right? So now this is a correct definition. So now let's go ahead and run this. Okay, sum of 3 and 4 is 7. So that works. Now if I was to do a differentiation, I would have to write again the signature of a function here, or declare it. Now instead of doing this, I can put all the declarations in one file. So I can add here a header file, and that header file is supposed to have the same name as the library or the implementation. And the reason is that is the only link between the library and the header, right? So you have to name it the same. So I call this as math func.h, right? So it should spell the same, math func.h. Okay, so in this I can do here int sum, which is going to be int a comma int b, and that's it, and that's the signature of the function. Then I can do int diff and int multiply. Control C, Control V, and I can say here diff is going to be that, and signature of multiply is also the same, mul and that. So basically, okay, so basically I have defined a header here, header file, and that header file can be included as a hash include. Okay, and then I can put here as math func.h. So I have included the header file here, so I need not now do a declaration of a function here. I can use any function. So let's say if I debug this, okay, so sum of 3 and 4 is 7. Now I can do the difference. Difference of 3 and 4 is -1. Okay, is -1. And then I can also do a multiply here. So this becomes very easy, and I can cleanly maintain my code in different source files here, right? Now the difference between .h and .c is nothing actually. This is just the same. Okay, so now I wanted to show you, let's say in my header file, so in my math file, I have a global variable, and I will call this as float, and I can say pi is equal to 3.14, right? So this is a global variable. Now if I want to use this global variable in here, then it has to be specified here as extern external float pi. Okay, and so that's taken care of. Then I can do here printf percentage pi is then percentage f, then new line character, and there I can put here pi, and that works, right? So let's see if it works. Okay, so the pi is 3.14. So that pi is a global variable over here, which I have passed it over here into the uselib.f as an extern global, right? So the header file can be used for function declarations and global variables, right? So this is on header files. So that completes chapter 10 in C. Chapter 11 in C is about the deprecated functions which could not use earlier, right? So let's try to use them. Chapter 11 in C. And moreover, I wanted to cover here console IO in more detail and string.h. So working with the strings. So here I am going to create a new, add an item, and I'll call this as DEPRACAT, dot c. Right. Okay, here I'm going to do a very simple function from include stdio.h. I'm sorry. Okay. Okay. So here I want to do a printf first name. Okay, enter your first name, and that's all I'm going to print here. Then I'm going to say scanf. Then I'm going to put here, I'm going to read the name, so I need a string. Now when you read from console or from any other input, the issue is the overflow of the buffer which you have declared. That's why this scanf is not safe. That's why it's going to point to that. So let's keep the length of the string to be fixed. So for example, I can say character first name, and it's going to use 20 characters. And then you can say character last name, and I'm going to put another 20 characters. Right. So here I'm going to say scanf percentage %s. So I'm trying to read a string, comma, and I want to pass a pointer to a string. Right. So now if I try to debug this, it's going to come up with this thing, CRT secure no warning. So basically this is a warning that this is not a safe, because it is prone to overflow. So if you type a very large input text a string, then that's going to give you a problem. So here I am going to add a macro here which says hash define, and here I can put that CRT warning, CRT underscore secure underscore no warnings, no warnings. Okay, sorry. Okay, so I have defined that. Okay, so now let's try to debug this. So now what's the problem? Okay. Printf, printf. Okay, that's the problem. Sorry, typing mistake. Okay, so it's asking for the first name. Okay, so I need to create a gap here. That's all what it is. So it is working now. So I would just put a gap here. So then I'm going to read the last name. So enter your last name, and in this case I can do a new line feed to make it clear, and I am going to read the last name. Okay, so then I will display what I have just read. So what I'm going to do is I'm going to say character full name is equal to okay, so here I'm not going to do that. I'm just going to do as str copy, str get concatenate. Right, so that would be there in string.h. So I will put here hash include, and then put here string.h. Okay, so now I will have strcat available. to concatenate. So the destination string is over here, which will be again first name, and then I would put the last name here. Now here I need a gap between first and last name, so I will do two str copies, one with the gap, and again I'm going to use strcat first name and then last name, and that, and then I will print this, printf percentage s. Okay, then here's the name you entered is percentage s, and here again I will put in a new line character, and here put it first name. Okay, so let's see if this works. Okay, enter your first name is Anurag and your last name is Nigam, and the name you entered is this, so this is working. Let me see if I'm recording. Yes. So another thing is that I can also input the what you call integer, right? So I can create an integer here, let's say age, and you have to pass a pointer in the scanf all the time, and then the scanf is going to read a string, and as soon as it encounters a white space character, it's going to terminate there. So if you try to enter, for example, here Anurag Nigam, then it will only read Anurag, right? So you will know this when I run this again, and let's say I enter Anurag Nigam. Okay, why did it just skip the last one? Okay, let's try to run this again. First name is Anurag. So as soon as you put in a space, it assumes that to be a second string, right? So it didn't ask for a second string, it just printed it, and it's assumed that the second string was there. Is that what this is? Okay, so let's check this out. What does the second string have? So I am going to comment out these. Okay, and let's see what happens. Build. First name is, let's say, Anurag Nigam. Yeah, so why did it? Okay, it took an empty string as soon as you put that space and then an empty string. Okay, so let's say if I run this again with just Anurag, then it'll let me do the second scanf, right? So I can do Anurag, then I can do Nigam. Yeah, so that makes sense. Okay, so that's what is happening. Now, to avoid that problem, instead of using scanf, I could have also used getString, and then I would just provide a pointer to the first string, and then again here I can put here getString and pointer to the last string, and then that's going to work now. But this time the problem which we are facing is not going to be there of white space character. Okay, so it is asking first name, then it's asking last name, then it's printing it. So let's run this again. Okay, so let's this time type this, and still asking the second string. So it is done this twice after concatenation. So you understood the difference. As soon as you put a white space character, fscanf has a problem. It's going to take the second scanf along with the first. So that's kind of mixed up. So if you want to take strings with white space characters, use getS. Similarly, you can put s also instead of printf. So both work. So having done that, let's try to read the age. Okay, so I can say okay, I can say printf. Okay, and here I can say new line, enter your age, right? And then I can say scanf percentage s sorry, percentage d, and then I have to pass a pointer. So scanf always accepts a pointer, that, and then I can say printf the age you entered is, okay, it has to be in the double quotes, it's a string, and then here I can do a percentage d and comma age. So this is going to display what age I have entered, right? So let's build that and run that again. Okay, I can put the first name, I can put the last name, and I can put the age. So the name you entered is this, the age you entered is this. Okay, so this is about that. You can similarly read float and stuff like that, right? Okay, so this is okay. So this is going to uh, ask the user for input for age, and it's going to print that. Now these are called formatted inputs, right? Now besides that, there are some unformatted inputs. Okay, so example of this get s and uh, put s is unformatted input, right? While is that, yeah, so now the other unformatted input is get character or get ch, get che, and get char and put char. So as the name says, get char and put char is going to put the character onto the standard output. Okay, put chr is going to do that. Get chr is going to get the character from the standard input, which is the keyboard, right? So in this case, as soon as you enter a character, you have to press the enter. So after you put the character, or after you scan the character, when you press enter, that assumes that the character has been entered, right? So that's get character and put character. Get ch is not going to wait for the enter. So as soon as you enter the character, it's going to get the character. Okay, get che is basically not only gets the character, but it is going to echo that character. So that's get che, and that all these are going to be declared in include file, which is called conio.h, right? So get ch, get che, get character and put character. So you have to put here conio.h, right? So that's other way of getting characters. Now something about string formatting. So let's say I wanted to print this with let's say 10%10d. So this is the fixed width, right, for this. So when it's going to print, it's going to print first 8 empty characters, and then let's say if I enter 2 digit, it is going to put here whatever the age is. So let's debug that. Okay, first name is Anurag, last name is Nigam, and the age is 28. So now you see that it has created this 8 character gap in here. Now if I want this to be aligned to the left, I would have put -10, right? So if you want to be to align this, so for example, I can do this way, that I can print age 2 times. Okay, so I can again do a percentage -10d. Okay, so it is going to do a left alignment for that. So the first two characters in this 10 character wide space is going to be occupied by this age. So let's build that. Okay, forgot it. I'm going to just do Control C. Okay, forgot to put the age here. Age again. Okay, so let's do this now. What's the problem? Okay, that's fine. So if I now do this, it's going to be in 28 two times. One time it's going to be right aligned, other time it's going to be left aligned. So let's say Anurag Nigam, and then I enter the age is 28. So it has left 8 characters printed 28, then it has left 1 character as in the string, and then it has put 28, and then it has left 8 characters here. So this is for formatting the tables when you enter here. Same thing is that let's say if I enter a floating point number. So if I enter a float, okay, and call this float as any meaningful float. Okay, let's say water. Okay, and I will put the water in liters, right? So I can say here scanf. Okay, and I can do percentage. So formatting in a scan is not going to be of any use, right? So you do need not put some as your formatting characters in the scanf, right? So here I'm going to say ampersand, and I'm going to say here water. So I'm going to print what is water. But then before that I have to prompt the user to enter how much water they have. So let's say I do printf, and I do a formatting string and say how much water in liters, and then I'm going to enter that. Okay, and then I'm going to scanf that, and then I'm going to print it, right? So let's say the okay amount of water you have is percentage. Okay, so this is before the decimal point, and then this is after the decimal point, and this is going to be aligned to the right. Okay, and here I can remove this. Okay, so let's do that. Okay, so first name is Anurag, last name is Nigam, enter age is 28, my age is 28. How much liters of water I have? I have 23.45673 liters of water. Okay, so let's see what happened here. I didn't give it water. Sorry. Okay, let's run this again. Okay, so it's over here. So I have this is Anurag name 28, and I have 23.45637 liters of water. So what it has done, it has to have a total of 8 characters. So now it has 5 over here. So it has to have 10 characters, and it has 5 over here. So 5 characters are left in the start. And then you are putting 2 points after the decimal. So that is your 0.2f. So that's how you format the strings. Now there are, you can read a lot of stuff on formatting strings, but I'm hardly going to use this console IO for doing this kind of table representation. So let's go ahead and look at have we covered everything? Okay, few more functions in str. Okay, I can copy a string, for example. So let's say I can do char and then say full name. Okay, and let's say its length is 20, and then what I'm going to do is whatever I have concatenated, okay, then I am going to do strcpy. Okay, and here the destination string is going to be full name, and then the source string going to be first name. Okay, and that's it. So here instead of that I can print full name, so that would also work. And I can say printf your name is X characters long. So if I want to do that, sorry, what did I do here? Your name is %d characters long, right? And then I can say strlen, and I can put here full name. Okay, note that the string ends at the null character, so it's not going to take 20 as you have specified at the top. Okay, so let's debug this again. Okay, so first name I have entered is Anurag, last name I have entered is Nigam, and your name is 12 characters long, so including the white space character in between. And then you enter your age, and how much water you have is 23.4523 whatever, and that's it. Okay, so here I have looked at two of them. One is strcpy and then strlen. Now I also want to compare the strings. So if the two strings match, okay, so it's basically going to return a boolean, or in this case it's going to return a integer. So if it is going two strings match, then it's going to return. So I am going to do printf, and I'm going to compare two strings. Okay, then I say is full name same as first name, and they have to be because they match character by character. Then I do %d, and I say strcmp, and here I can say full name comma first name. Now this is going to return a 0 if strings match, and it is going to return a number where the first character mismatch, the difference of that character values, that is going to return. So here I can say if you want true, I can say not of that. That's the convention. So if it gives 1, that means that the two strings are same. So let's do that. So I would enter a first name, then I would enter a last name, then is full name same as first name 1, so that means it's true. Then age is 28, and water is 2342 something. Okay, so here we have looked at some of the functions which are declared in string.h. We have seen stdio.h, printf, scanf, getS, putS, and stuff like that. Then we have also talked about some functions in conio.h like getch, getche, getChar, get put character, and whatnot. Now there is another thing which is called scanf, right? I can put I can scan multiple things on the same line, but then I can, instead of directing it to this, I can direct it to a string. So I mention a string and then the formatting string, and then I can basically read, right? So that is scanf. So hardly I'm going to use that. So this completes my chapter 11 in C, right? This is chapter 12 in C, and this is a concluding chapter. And here I'm going to talk about file IO. So what I'm going to do is I'm going to create a new project, an empty project, and call file IO. Okay, and then say OK. And this is an empty project to which I'm going to add one file as a new item, and I call this as read write, right? And this is extension C. And here I'm going to include two files, and as required I'm going to include other files. So first file I'm going to include is stdio.h, and the second file I'm going to include is stdlib.h. std hash include stdlib.h. Okay, and in case I require a boolean, I would include std bool.h. Okay, now with this I can just start writing main, and it's going to receive void, and here I'm going to write my code. So what I want to do is I want to write to a location, and that location should have a write permission. So otherwise, it will not succeed. So for example, in this, let's say go to desktop and DSP images, right? So just I'm going to write to this folder. So I'm just going to look at the properties and say the path is over here. So I'm just going to copy that path. Okay, and here first of all I have to create a file pointer. Okay, so the pointer to a file is going to be created like this. Then the next thing which I'm going to do is, of course, all these commands are going to be your deprecated ones, so I will have to add a hash define here. Hash define, I think it is cts secure, no warnings. Okay, so I have defined that, so that's going to work. So here I am going to create, I'm going to have a string which I want to write to, let's say, a file, and I call this as my message. Okay, and that my message is welcome to C. Okay, and here I can open the file, so I will try to open this file. So if I say f open, and then I have to provide the path to the file which I just copied, and the name of the file. So I can name this as message.txt. So this is going to be a text file, and then the mode is going to be the mode of writing. So what this is going to do is this is going to search for this file. If it exists, it's going to replace, it's going to overwrite it. If it doesn't exist, it's going to create it. So once it is done, I have to check whether the pointer is, if fp is not equal to null, that means that it has been successful in opening the file in the write mode, right? Then I'm going to do something, right? So now here, first thing I want to do is I want to write something, right? So I can say f put s. Okay, so this put s and get s are unstructured IO, right? And if you put f in front of it, it is for the file. Similarly, get ch and f get ch, put ch, f put ch, right? These are all your file commands, right? Which are for unstructured. Then you can still use a fprintf and fscanf, which is formatted writing and reading. So instead of reading from character by character, I want to write the entire string, right? So f put s, it says that what I want to write. I want to write here my message, and then I want to write it to this file. Okay, so when this is done, I can say f close. So I have done what I wanted to do, and here I can say the pointer which points to the file which I want to close. So this is there. So right now you see that this location doesn't have message.txt. So if I run this, okay, let's see what happened. CRT secure, no warnings. So there's a mistake here. CRT secure, no warnings. I'm going to run this again. Okay, so it has done something. Let's see if it has written the file. So let's press escape. Okay, the problem here is that this string, this path cannot be found, right? Because this refers to escape sequence. So this is a verbatim string. I think it works in most cases, but here it is not. So in that case, I would have to put escape sequence for these. Okay, so after I put the escape sequence, let's see if it works. Say build this and say enter, and if I go to this location, I see message.txt, and if I open it, I see welcome to C. So I have written to this file and I have closed this file. Now if I want to append something to it, so this is opened in write mode. Now I can open it in append mode and add something to it. So I can go here and say open it in append mode, so that don't overwrite it. And then I want to put a message. Let's say, darling, I am home. How's that? Okay, so this piece of text I want to write, but then I want to enter a new line character here. So one thing I want to remind is, if I use a new line here, it is replaced in the file by two special characters. One is the carriage return and other is the new line feed. And when I read back, the carriage return and new line feed is read back as a new line character. Okay, carriage return and new line feed is read back as a new line character. So here this is something which is just information, right? So now we have opened this in append mode and then closed it. So now let's run this again. Okay, press enter, go to the file is over here, and I have added another line to it. So now let's say I want to read this text, right, and then display what was written. So I can open the file in read mode. So I can open the file in read mode. Okay, so when you do a text, okay, then if you read character by character, then the last character in the file is going to be decimal 20, the digit 26, which is the end of line character. So you can always use the end of line character to mark the end of the file, right? So whenever you do that, the last character is going to be end of the file. So if you read character by character, as soon as you encounter end of the file, you can terminate the reading. But if you read by the strings, okay, so then in that case I would see if I do a null, right? So for example, here I am going to open this in a read mode, right? And then here I am going to write while true. Okay, I'm going to do something. Okay, so while true, I'm going to do something. So I'm going to do this, the following: if f get s, okay, and here I would specify where I want to read. So I have to create a read message here. So here I have to give a certain size to my message so that there is no overflow issue, right? So read message, let's say 80 characters, and read message, right? So I want to read message, so read msg, okay, and then I want to read last but one character, so let's say 79 characters I want to read from fp. Now if this is equal to null, okay, if this is equal to null, right, then I am going to exit, okay, and I'm going to give, so I'm going to exit like that. Else I'm going to print, okay, I'm going to say print f, and I'm going to say %s, and I'm going to print read message. Right, and so that way I'll read line by line. So now remember, there is going to be a new a carriage return, that is /r, and a line feed l, which is going to be read back as a new line character. The combination is going to be read back as a new line character, and the second message will come below the first message, right? So now we are all set with this. Let's build that. So if you want, I can remove this message.txt. It will create it again. So here I'm going to say debug, start without debugging. Okay, it says welcome to C, darling, I'm home. Okay, so it created the file, which is over here, and then it read it back. So this is about the opening the file in the text mode, and in that case you can use formatted printf, fscanf. You can use your unformatted fget c, fget fput c, fget s, fput s. You can put fget car and fput car. You can use fget ch, fput ch, and so all this you can use for unformatted, right? And mind you that the end of the file is going to be a text file, is going to be a character which is called end of line, EOL, and it's defined as a macro in std io.h, right? And it is its equivalent d is equal to its equivalent integer value is equal to 26, while in binary file this is not what it is, right? So in that case it is going to look slightly different. So now what I'm going to do here is I want to open a binary file, which this exercise is important because I'm going to use this in image processing also. So what I have here is I'm going to open a BMP file. So I have number of BMP files here. So let's say this audrey.bmp, right? So basically if I open it, okay, how come it's so slow? Okay, so this is Audrey Hepburn. So this image I want to open and get all the information about the image, and then I want to read all the pixels and store them in 3 arrays for red, blue, and green. So this I want to do here in this exercise. So when I open this, I will open this in a binary, read binary, right? So let's do that. Okay, so what I want to do here is let's say file, and then the pointer to the file, right? And then I'm going to say fp is equal to fopen, and this time I'm going to open this file location. So I'm going to go here and say right click properties, and this is the location of the file. So I'm going to paste that path over here, and here I'm going to put the escape sequence for the backslash. Okay, and here I want to put the name of the file. So the name of the file is called audrey.bmp, right? So that's what I want to open. Okay, and then I want to open this in a read binary mode. So there. So once if it is done, then if fp is not equal to null, so that means it has succeeded, right? Then I am going to do something. Okay, else nothing happens. Okay, so now here let's say the pointer to the file is returned in fp. Now I'm going to start reading it, right? So to read this, I'm going to say unsigned int, not int, character, unsigned character ch, right? And I'm going to use fread and fwrite. So if you want to read and write in binary, these are the two functions, fread and fwrite. Okay, so I am going to use fread, and if it succeeds, it returns a flag which is 1, right? So what I'm going to do is, if I'm going to say, first of all, I'm going to put the file pointer to 00. So I use something called fseek. Okay, fseek, and here I am going to put the stream as fp, and then initialize the offset to be 0 and the origin to be 0. So that's the beginning of the file. Now I can place the pointer in other ways also. So there are certain macros defined, like for example I can say fseek okay, seek okay, so seek current. So from the current I can specify the offset. Okay, so from the current the offset can also go negative. Let's say one whatever is the size of the in case of binary, it is going to be the size of the variable, right? So if it is an integer, it will be 4 bytes. If it is a short, it will be 2 bytes. If it is a character, it will be 1 byte. So if I do -1, it will go by that many bytes into the size of that variable. That many bytes is going to go back, right? So here I am placing this at 0 offset from 0 origin. Okay, once I have done that, I want to see what are the what is the first character. So I can say if fread okay, if fread, so I'm going to read it into the character ch. Okay, what's the next thing? It says size of the element. So I will say size of character, right? Size of character. Then the next thing is going to be how many such units I want to read. One character I want to read, and from which file pointer? This file pointer. So if this thing is equal to 1, that means that it has succeeded in reading, right? Else it has failed, right? So in this case, once this happens, I can say printf, and I can say I want to print %c, and I want to print ch. else I'm going to do nothing, right? So else I'm not going to do anything. Now the last command I'm going to have is I'm going to close this file. So I can say fclose the file pointer fp. Okay, so I'm just reading the first character, and the first character, if I go by the header of a BMP, the first character is going to be B and the second character is going to be M. So I want to see whether it is B and M. Okay, so here I can say start without debugging. So it's read as B here. So you can see this is read as B. Okay, so the second character is going to be M. So I can repeat the same stuff, right? So here I can just not put a if statement. So I'm seeing that it succeeds. So I'm assuming that this is also going to succeed, right? So if this is succeeding, then I can say printf the second character. So the file pointer, as soon as I read, the file pointer is updated by 1 byte and is pointing to the next character. Okay, so it is this time it's going to print BM. So it prints BM. So it has read two bytes from the file and it has displayed that. So basically the header says this is BM, right? Then you can create a structure, right? And that structure is going to have integer, integer, and integer. So there are going to be 3 integers here, right? So let's create a structure like that in which I'm going to read this. So I can go here and I can say struct and give the name to the structure as BMP info, right? So I will call this as BMP info and bit info. So I will call the okay, so instance I will come later. So this is structure I want to create. Okay, and this is structure I want to say unsigned sign int and expected an identifier. Why? Struct. So I'm creating a structure. I don't want to put an identifier here. I can put the identifier later, no? Okay, so let's see unsigned int. And this is called signature. Signature is done. File size. Okay, so I will call this as file size. And then I am going to say unsigned int. And the next thing I'm going to say is reserve word. So that is going to be res word. Okay, next is going to be unsigned int. Then, so there is certain problem here. Unsigned int, and here I am going to read data offset. So basically this is offset from where the data is going to start. So data offset. Okay, and so this structure is complete. Then I declare one instance of that structure. I say BMP info, and then I am going to say bit info. So this is the information about my BMP file which I'm going to store here. So that one I'm going to read over here. So in this case I'm going to say fread, and here I'm going to say I want to read it. So I have to give a pointer to this. So this bit info, okay, is a pointer, right? So bit info comma, the size of elements. So what's the problem here? Okay, you have to give a address. Okay, then the next thing which I'm going to give here is the size. So size of, I can say bit info. That's the size of the structure, comma, one structure I want to read from FP. So the file pointer is going to be incremented by the size of the bit info. So I'm done with this. Now I can print f percentage %d. So I'm going to put new line %d. So I want to print 3 integers %d and new line %d. Okay, so that are going to be bit info. Okay, dot. So I'm going to read the file size, comma, bit info dot. I'm going to read the reserve word, comma, bit info. Okay, bit info, comma, the data offset. Okay, so let's calculate what this means. Okay, so in this case, this is not 8-bit, this is 24-bit image, so it doesn't have a color map. So what it means is there is going to be 14 bytes of this bitmap information, and then there is going to be a header which is going to be 40 bytes. So then the data would start after this, which will be 54 bytes. 14 plus 40, 54. So the offset should come as 54. Okay, so now here, if I run this, okay, so it says BMP, and it says how many bytes is it? It is 786486 bytes, and this is a reserve word of 0, and the offset is 54. Now let's compute the size. So the bitmap is 512, right? So if I take out calculator, so 512 multiplied by 512 multiplied by 3 bytes for 3 colors, right, is going to be this. Okay, so that's going to be the size. Okay, now here this is the data size plus 54 of the header. Okay, so the size is going to be 786486. So that's the size, 786486, right? So everything is counted for here. So this way you can read the bitmap into the array or into a memory location using malloc. You can read those red, blue, green images, right? And you have all other information also, which you can make another structure, and you can read the information like, what is the size of the header, what is the width of the image, what is the height of the image, how many planes are there in the image, how many bits per pixel is there a compression, what kind of compression is there, okay, what is the image size if it is compressed, if it is uncompressed it is going to be the same, and how many pixels per meter, right? How many pixels per meter means it's the scaling, x scaling, y scaling, the number of colors used, and the important colors, right? So let's say if I want to find out the width and the height of the pixel, right? So I have to place an offset. So this is 14 up to here, then plus 4, that is going to be 18. So I'm going to place the file pointer at 18. Okay, and I want to see if I can read width and height. Okay, so let's do that. So I am going to put here fseek. Okay, so I'm going to place the file pointer to a location which is offset of 18 from the start, right? So that places the pointer there. Then I'm going to read it, integer, right? So I can create here unsigned int width, and then I can say unsigned int height. Okay, so first thing I'm going to read is going to be the width, and the second thing I'm going to read is the height. So let's close this. So let's go here, and I can say fread, and I want to read the width. So I can say width, and then I want to see, say, size of, and I want to read 4 bytes, which is size of integer. And then I'm going to say I want to read one integer only, and then the file pointer is fp, right? So that's going to be the width. Now I can also do a fread, and I can say ampersand height. Okay, so height, and then again size of integer, and then number of integers is 1, and then whatever is the file pointer. Okay, and then I'm going to display that print f width is equal to percentage d, and height equal to percentage d, and here I'm going to give width comma height. Okay, and that's done. So I'm going to print the width and the height. So I know the width and the height of this image is 512. So if I point here, it says dimensions are 512 by 512, right? So let's see if it does that. Start without debugging. Okay, so width is equal to 512 and height equal to 512. So basically you have all the information which you can read from a file in a binary mode. And similarly you can do a fread and fwrite. And the fwrite, so here you cannot do fwrite, but let's say I want to just show you the syntax. Fwrite, and what is it expecting? Okay, it is expecting the pointer to what you want to write, then the size of the element and number of elements and the file pointer. So this is just same as the fread. So you'll be able to fwrite. So now with this you can get started with some form of image processing, right? Okay, so this basically completes chapter 12, and this concludes the session 0 on programming in C. Thanks a lot. Thank you.